back. Yeah, so I don't actually know what happened there, guys. Here's my materialized query table. Is this the right query table though? This is the correct one. This is the wrong one, guys. Okay. Okay, looks like we're live again. Alright, let's keep going. I'm probably gonna have to say keeps cutting out on the title at this rate. But let's see. So we're not. Where's our SQL? Because I think if it surely it's the cloud, so like everything's saved. Where are my scripts? Oh, but did I lose all my? I lost all of them. Wow. So if you don't save one of them, you lose them. Oh my word! I lost my scripts. Uh. Okay. I guess I lost all my scripts. Not cool. Whatever. I'm gonna have to save this one. Where's my save button? All right. I'm gonna remember the save button. Okay, let's do the let's make a materialized query view. Select year. What is it? Is it sorry? Create table. Create table. Country. Stats. Table country stats. With the columns as follows. Country. What is it? Country. Is it country and year? Because I need to get this right. It's country year sum. Okay, country year sum. Sorry, country year sum. Build mount. Okay, there we go. Yeah, exactly. Doing it for the fans. Exactly. That's the only reason. So as. Okay, here we go. Sum build amount. That is correct though, right? Oh no, that's not correct. What am I doing? What am I doing? That's not even necessary. Okay, as select. Now we just select country. We select year, I suppose, and then we make a sum of the build amounts. Summary would actually probably be a nice term. Amount. Let's keep going. So where were we? So we did select. Okay, this is not quite done yet. So now we want to do a whole bunch of okay, wait, from fact billing. Okay. Then we say left join dim. Because I just want to remember the last one. What is the last one? I don't think we need to really care about this because I feel like I've gone over this already. But what is the last one? There was one that I missed. What is the one that I missed? Which is the one I missed? Yeah, data initially deferred, refresh deferred, maintained by system. Okay, that was the one I need to know. Customer. This is so annoying that I have to do this. On dim customer. Dim customer dot. Oh, sorry, what am I doing? What am I doing? This is so bad. I'm so bad. So facts billing. Like we actually have a goal here. Fact billing dot customer ID equals what is it? Dim customer dot customer ID as well. Very nice. So what are we missing here, guys? We want another left join, exactly. So left join dim month, very standard, and then I think we join it with fact billing, famous fact billing. The customer, sorry, the month ID, because that is the key. Okay, month ID equals dim month dot month ID. Let's see. Okay, so we've done this. Group by year. Oh wait, is this? Am I going crazy or something? Am I just going crazy? Okay, is this necessary? I don't think it's necessary, right? Whatever. Let's just make it the same. Group by. Oh, is it order by? Country and year. Oh, so what am I? So making a mistake, basically? Oh, no, I'm not making a mistake? Okay. Well, I guess you have a lot of options, so fair enough. They also do it in brackets. Yeah, you don't actually need. Yeah, that's what I thought. Okay. Country, year. Let's keep going. Country, year. And then we have data initially deferred, refresh deferred, maintained by system. Data initially deferred. What is it? Data initially deferred. Refresh deferred. I don't want to. I want to get it wrong. Refresh deferred. Yeah. Refresh deferred. That's not too many R's. Refresh deferred, and then maintained by system. Okay, let's finally run this query. All right, let's run this query. Hopefully it works. Be patient, guys. Be patient. Okay, let's save this as well. Don't delete. Don't delete me, IBM DB2. Don't delete me, IBM DB2. Cloud, like you did last time. Alright, there we go. Simple. Change the name? Okay, I'll change the name. Hang on. Yeah, definitely change the name. Yeah, the name could be changed. Multiple query table for country stats. Yeah, that's way better, right? Okay. It does actually take some time. Everything else is like instant, but this is taking some time. So rule number 1, like save your queries. If you're in DB2, save your query. Okay, so you may get a warning as output below. Okay, data initially deferred by the system. Simple mean the data is initially populated into this materials. Wherever the underlying data changes, the materialized query table does not automatically refresh. The materialized query table is system maintained and not user maintained. So the goal is, yeah. I don't know. Okay, the goal is to system is maintained. Okay. Keep going. Step 2: populate or refresh data into the materialized query table. Execute the SQL statement below to populate the materialized query table country stats. Okay. I would love to. Oh, there's some practice. Okay. Yeah. But the thing is, this is taking so long. This is taking actually really long. I thought materialized query tables would take quicker to be created, to be honest. But yeah, in the meantime, we could actually do the week 3. Yeah, definitely. Okay, let's go to the week 3. Let's do it. Okay, so while we wait for this thing to load, we probably will need the DB2 console as well, which is going to be a bit strange. Okay, so we have all the prerequisites, service credentials. We have. Okay, let's read through it carefully. IBM skills and IBM create dashboard and record. Analyze the reason why it's okay. Create an average prison. I guess take the other day in DB2. Skip steps 1 and 2. Okay, so we can skip steps 1 and 2. So now we're on step 3. Click on the. Okay. Let us go to my IBM. All right. Still waiting for the table. No signs of progress right now. Okay, let's keep going. Password should auto-gen. Okay, let's go here. Yeah, I don't want to leak my password. That's the thing. I'm scared. I'm scared of that. That does scare me. That does scare me, guys. Okay, loading your products. There we go. It's launch. Oh wait, that's not what I want. Oh wait, what do you mean? Oh, they actually do mean this. So I actually was in the right place. Okay, let's go back. Just, it doesn't matter. We just got to keep going. Create table country stats failed. Well, I wish there was a reason I could fix. I wish there was something I could fix. Like, I don't know how is this the query? Is my query wrong or something? Or okay. Is it because there's no? Okay, this. Okay, let's try this. If that's the change, I mean, I don't think it's okay. Let's keep going. Okay, so let's go to IBM Cloud. This table's not creating. Yeah, I don't know why it's not creating. Yeah, IBM, come on. This is meant to be an advertisement for you. Let's go to services. It's 5.4 running. Okay, so TB2, that's where we need to go. All right, excellent. We're getting somewhere. As for TB2 here, I'm afraid I can't really say too much because there's not much I can do. There's not much I can do, unfortunately. Can I run multiple queries, then it gets locked? I don't know. Okay, let's keep going. Okay, we just need to go to the service credentials. Okay, service credentials, and then we have to go to username and passwords. Okay, click on the down arrow to the credential. You'll see the credential details. Make note of the username, password, JDBC connection URL in the lab to Coursera. We just need the JDBC. Let's see. I think I've seen that before. JBDBC. This is it. This clearly is it, right? So I just put my user and password in here. All right. So this actually is coming together a little bit. I'm just not going to make assumptions. Click on the down arrow next to your credential. You'll see the credential details. Make a note of the username, password, and JDBC connection URL. This will be used later on in the lab to connect from Cognos. All right, cool. Note, you have to replace the placeholder for username and password in the JDBC URL string with actual username and password. Remove the angle brackets. Go to the data link. What do you mean? Wait, go to the what? Go to the data link, right click as cloud billing. Go to the data link. Okay, is this it? Is this it? Wait, am I going crazy or something? By the way, we haven't even it says 1 hour 38 we've been studying, but that's obviously not true. This is a text document? Wait, what? Why is this? Okay, this is not what we want. We don't want text. We don't want text, guys. We don't want text. We want .csv, right? Does it save as .csv? Let's see. Okay, it did. Okay, excellent. We have it, guys. We have it. Oh, once the instance is created from the DB2 instance, choose manage them. Click on go to UI. No problem. Go to manage. Go to UI. Let's go. All right, let's keep going. All right, so we've gone to the UI. Click on the data icon on the left. Click load data, cloud billing data, which you have loaded into your local system. So clearly, this is a pretty long lab, by the way. Because what is the thing we had to do in this lab? I think we did all. all the other stuff. I could almost say I did the other lab, to be fair. But to create it, wait, what? To create a dashboard with billing data on DB2 using Cognos Analytics and analyze the region-wise speed. Are you talking? Okay, let's keep going. Load data. Where's load data? Okay, so we have this. I think this is load data. I think file selection is correct. I'm just gonna make a few bad assumptions, or maybe good assumptions. Let's go on. So here, let's keep going. Cloud billing, right, guys? This is the correct one, right? 6 megs. Geez. Okay, so we put that cloud billing there. Choose the schema, click on new table, and create a new table with the name billing data, and click on create. Okay, so we want to call it, sorry, do we need this? I think we do for credentials, so let's keep that. Okay, next. Now we choose our schema. This is our new schema that was created a few days ago. Okay, and as you can see, there are a few tables in it. Are you ready? All right, now what is our new table we want? Billing data, what is it? What is it? Billing something. It's billing something, right? What is it? Billing something. It is table with the name billing data. Okay, billing data. Billing. Just want to make sure it's right because yeah, you kind of want it. Okay, billing data. Let's keep going. Let's create. Now where's my billing data? Billing data. Billing data. Okay, billing data, whatever. Okay, there's our. Oh wait, this is. Oh, there it is. It's worked. It's worked, guys. It's actually worked. It's actually worked. So now we have to decide: do we switch tasks and just go straight back and finish this? Oh man, I don't like. I'm not multitasking. I'm not gonna do them at the same time, but I did say we would wait. So let's go here. I think we've got the thing working. So, whoa, what is going on? Yeah, so it says the materialized query table may not be optimized for processing queries. You can safely ignore the warning and proceed to the next step. The above command creates a materialized query table named country stats that is 3 columns: country, year, total, build amount. A materialized query table is essentially the result of the below query, which gives you the country, year, and the sum of the build amount grouped by country and year. Select your country, year, build amount from if joins, slide customers, flip joins, group by customer. Yeah, settings. Data initially deferred, refreshed, deferred, maintained, or simply means the data is not populated. Populated fresh data. Data. Okay, let's refresh the data. Just save. Okay, if I'm gonna save, can I save? I can save, right? Can't save. What do you mean? That's bad. Okay. Create new. Refresh. Something. What is it? Refresh. Refresh table country stats. Table country stats. There we go. Refresh table country stats. That's pretty good, right? Refresh table country stats. The command above will populate with relevant data. So these are the data that is already in the. I have no idea what I'm talking about. Okay, refresh table. There we go. It's I guess it's refreshed now. It's populated, as they say, which is probably because this whole is called. Most of the things we've been doing is about populating a data warehouse, hands-on lab, populating a data warehouse. Command above, and then you query the data that you populated with. Command above populates the materials with relevant data. Query the materials. Once in a materialized query table is refreshed, you can query it or execute the SQL system below to query materialized query table country stats. Okay, so we're going to query it. Do some short queries. Okay, so select. I'm going to select. This is a view. It doesn't. Okay, select all from country stats. All right, select all from country stats. Let's keep going. Where's my pen? Okay. Right, there's our table. We can obviously look at it some more, but I'm worried it cuts out or something. But anyway. All right, so create a grouping set for the columns year, quarter name, and sum. Okay, so this is okay. I like this. Okay, so what do they want? Create a grouping set for the columns year, quarter name, sum, and build amount. Wait, but with wait. But wait, do you want me to do it with? Wait. Okay. Okay, I'll give an answer. Okay, I will take the hint in this one though, because I don't know what they mean. Make sure that this table contains the country and city of the store. Huh. Very interesting. Country and city of the store. But okay, so for columns, year, quarter name. So wait. I need to have. Yeah, I didn't feel like they being honest here. Okay, fact billing. Okay. All right. Okay. All right. It contains the country and city of the store. Okay. All right. Let's just do that, because it's obviously going to be a whole lot of people in the comments getting angry about me not doing it. But okay, so let's select. What did they want exactly? They wanted year, quarter name, and year, quarter name. Year, quarter name. Wait, what? Oh, so these are just literally okay. So these are just literally columns. What are they? What am I doing? Year, quarter name, build. Okay, sum of build amount, which is standard. I don't even know how many times we've done this, but I guess we've done it enough times. I guess maybe. Should we pause? I think we'll do well in the assignment. We'll see who grades our assignment. That'll be interesting. That'll be interesting. Yeah. Should we give them the link to the YouTube video? Yeah. Definitely. Okay. From fact billing. Select year, quarter name, sum, build amount from fact billing. Left join dim customer. This is the only dim customer. Left join dim customer, stay on topic. Left join a dim customer on fact billing dot customer ID equals fact billing dot customer ID, and then there is dim customer dot customer ID, dim customer dot customer ID. Then we left join again on okay, I gotta type fast. This is a speed run, guys. This is a speed run. The month on fact billing. You could also do it the other way, I suppose. We do it either way. Fact billing. Actually, yeah, me writing it out, I can do it whatever way. Because the month dot month ID equals fact billing. You can do fact billing dot month ID. And now you said, what did you want me to do? You said you wanted me to group the sets. Okay, so group by grouping sets. I think this is right. I'm not even sure, but I really think you would want year and quarter. You want year and quarter, right? Year and quarter, right? Yeah, year and quarter seems right. Okay. Did I get it right? It's year and quarter, right? Yeah, it's year and quarter. Chill. Okay, let's just run it to make sure. It should run though. If it doesn't run, then okay, so this mistake. Dim customer. Customer ID. Fact billing. Customer ID. Quarter name. Having clause or. Oh, sorry, my bad. Yeah, I see the error of my ways. Quarter is here. There we go. All right, let's keep going. Now, create a roll-up for the columns country, category, sum, and build amount. Now, I suppose I could write it all out again, but it just doesn't exactly make sense. But I could do group by, roll-up, year, and quarter name. So there we go. That is my idea of a roll-up. I think it's right. Let's see. All right. Group by, roll-up, country, and category. Oh, wait. Sorry, wait. I made a mistake. Country. So we want country and we want category. Oh, wait. I need to check a lot of things. Country and category. Okay, country is here. And then category is here. All right, category. All right, that's pretty good. Year, quarter name. Oh, sorry, what am I doing? Country. Country. And category. Category. Country. And category. And category. Let's see. Country and category. So let's see. This is the new one, right? This is correct. Yeah. So this one is correct. So this is the month, dim customer. The joins have. Do we have to try out the joins again? Okay, we'll do it for the next one. But brutal. It is brutal. Create a cube for the columns. Year, country, and category. Okay. Create a cube. Let's go from the top. Select. Wow, I need to remember year, country, category. Was it year, country, category? So year, country, category. Yes, year, country, category. Year, country, category. Year, country, category, and what is it? Year, country, category, and sum of the build amount. It's almost off by heart now. Build amount, and it is from fact billing. However, then you left join. Dim customer. Actually, let's do it differently. Why not? Dim month, and then you say on dim month dot month ID month ID on the month ID equals fact billing dot what is it, month ID as well, month ID. Okay, let's keep going. Let's left join again. And left join, where shall we left join? We are joining on dim customer. On dim month, okay, I must remember to do the washing of the dishes. Sorry, dim customer dot customer ID equals fact billing dot customer ID. All right, let's keep going. Now we say group by cube of we want, what do we want to cube? Do you want to cube everything? Okay, so we want to create a cube for everything. Okay, so year, cube, year. Open brackets, year, comma, country. Country. Oh, no, don't do anything. What are you doing? Country, country. And what is the next one? Country. And category. Jeez, I'm having struggling with category today. Starting with the word. All right, this should do it. I think you could order by year if you wanted to. It's just for an extra bonus for a side quest, but I don't know. Order by year, country, and category. Is that right? That looks so weird. I don't know if this is right. It is right? Okay. Alright, so this is this. Oh wait, yeah, this is this. Cube, year, country, category. Pretty much the same. We did a bit of extra. We did a side quest there, but to get some more XP. But we just chilling. We're just chilling. All right, let's keep getting some XP, guys. Let's keep getting XP. Create problem. Okay, create materialized query table named average build amount with columns year. Oh, this is it. Year, quarter, category, country, and average build amount. But no group by, right? No group by. Okay, so they just say create the... Okay, so we just do that, and then we're A4 away, as they say. Then we're gonna go on to hopefully finishing that week, and things can start looking good. But of course, it's a long process. Oh wait, what am I talking? Okay, so we click for the hint. So you create a name country queue. Okay, so we want to create a named average build amount. Okay, we create an materialized query named average build amount. So we're going to create a table named average. What is it? Build. But wait, what is it? Build amount. Okay, average what? Average build. Average bull amount. Average bull amount. Okay, average bull amount. So that's what we're gonna call it. Average bull amount. And what do we want in it? Okay, so we're gonna say we want some columns. Sorry, wait. We're gonna say we want some columns, and we're gonna do the columns as follows. As follows. Okay, so we have this. Let's see. We have columns, year, quarter, category, and country, average bill amount. Okay, year, quarter, category, and country, and average bill amount. But it doesn't say populate the view though. It doesn't say populate the view though. Okay, so let's just create the view then, because that's what they say. So, with columns year, quarter, category, country, year, quarter, category, country. Year, quarter. What am I pressing that's making that happen? Quarter, country, year, quarter, country. Sorry, year, quarter, category, country. That's terrible. Quarter, category, country. Year, quarter, category, country. Build amount. Okay, so these are all of our columns. So now we create our materialized view. Maybe we should say as, I don't know. What feels right? I don't know. What do you guys think? As what is it? So we do the statement now. Select. We want to select year, quarter, year, quarter, category. this R button is not in good shape, guys. This R button is not in good shape. Country country average, bold amount. Okay, so this is pretty good. Oh, sorry, what am I doing, guys? Guys, come on. You must tell me what you must tell me when I'm doing something wrong. Come on. Okay, bold amount. So now I'm referencing. Okay, relax. Okay, so this is selected from. Select from bold. Sorry, fact billing, and we want to do a whole bunch of joins. So first off, we start with the left join, dim customer, left join dim customer on what is it? Dim customer on dim customer dot customer ID equals fact billing dot customer ID as well. Now we move on to the next left join on dim month, and that is on let's just say dim month dot month ID equals fact billing dot month ID as well. Month ID. Okay, so now I think this is the select statement. Now we want to group by a bit. Oh yeah, sorry, group by. Sorry, wait. Group by grouping sets. You know what? Let's do it properly. Let's do a cube here. Why not? Let's do a little chill cube for year, quarter, category. Again, with struggling with category and country. There you go. So that would be probably the best cube I've ever seen, maybe. Okay, so now initially deferred upon initially okay. Wait. Oh, do I just have to know this? Well, it's right here. Data initially deferred, refresh deferred, data initially deferred, data initially deferred. Is it manually? What is it? What is it, guys? Oh, I keep messing it. Refresh deferred, then maintained by system. Refresh deferred and maintained by system. Refresh deferred and maintained by system. Alright, this actually looks pretty good. Does it work? Who knows? Let's check. Select quarter, country average, average build amount. Okay. It does give us a warning, but they apparently say that's not a problem, right? They say it's not a problem. You can safely ignore the warning and proceed. So I actually did some chill stuff here then. Maintained by system, data initially deferred, refresh deferred, maintained by system. Refresh table, average bill amount, corrections, Ramesh salary, Avahuja. Yeah, this looks pretty good. The OGs, Ramesh Sanaraji, shout out to Ramesh Sanaraji, Avahuja, the OG. And finally, we can mark this as complete. Yeah, we're getting a high completion, you know, we're completing all the side quests and the main quest as well. We're almost completed with the main quest. Alright, let's keep going. So the main quest is, let's go back. So the main quest is to actually get the Let's go. Wait, is that right? Okay, so we're doing. Okay, let's do this. Okay, so this is done. Okay, so this is done. We don't have to worry about it anymore. Could I just exit all of this? I think I'll leave this open and let's see. Let's leave this open. This open as well, but I'll leave it open like this for now. And actually, yeah, leave it here, and then I'll put this one. I think this one we need. Okay, so this can go, and this can go. All right. Let me just check if we're still live. I think it's pretty good practice to check if I'm still alive. Does look like we're still alive. So I think we've done like there's 2 hours of recorded footage of me studying, so pretty interesting. And we've done 40 minutes in this sesh so far. Well, the sesh before it cuts out. I mean, hopefully it doesn't cut out. If it doesn't cut out, then it's just like the full working period. Guys, focus. Stop talking about nonsense. Okay. All right, stay on topic. Stay on topic. Okay. We have our. What do we have? We have our. Okay, where were we? Okay. All right. Now it's a total different scene. Let me get some water. The streamer's trick, the classic streamer's trick. So good, so good. Okay. Okay. Let's see. Wait, okay, where actually were we? So we were at here. Okay, again, now everything just totally switch, like totally switch. Oh wow, okay. Well, this is okay. So where were we, guys? Where were we? Where were we? So we've okay. Where were we? Where were we? So we went to the data link. Right-click save. We have saved the file as cloud building dataset. So we've done that. Once this is created from two, choose manage them and click on go to UI. Okay, I think we've done this. Click on the data, the load data, cloud system, load data. There we go. So choose the schema, click on create. Okay, so now it says, yes, it's that. And then it says, you'll see the tables added to the scheme. Click on next to load data from the file. Okay. All right. The table is loaded. You will see that each column has data type and column which is based on the content. Edit column attributes by clicking on the pencil icon next to the respective area to change the width of country column to varchar of 30. So country column to varchar of 30. Let's change it to 30. Maximum number of characters to 30. All right, edit column, data type, data characters, Indonesia, core, maximum number of characters, 1, 2, 3, 32,592. They say 30, right? They said 30, right? Yeah, to varchar. Okay, month column to varchar of 7. Where's month, guys? There's month. Okay, hang on. Gotta get to month. Month. Varchar of. Oh, they say okay 7. Okay, month varchar 7. All right, so month maximum carried varchar data month. Okay. All right, 7. All right, varchar 7. Oh, was it not varchar? No, it was varchar. What are you guys talking about? Okay, where's the Yeah, I know I'm literally talking to myself. I don't care. Even if there's no one in the chat, I don't care. I like pretending that there's people in the chat. Okay, country varchar 30. Okay, let's go here. Let's focus. Stay on topic. Varchar 7. That's correct. Varchar 7 and country is 30. Okay. All right, looks good. All right, now what do we do? So we've done that. We've done that. Once the column attributes are changed, check to see if it reflects and then click on next. Okay, once the column attributes are changed, check to see if it reflects and then click on next. Okay, so oh wait, they have changed? Okay, so it's right then. Okay, so then we can click on load, I think. Okay, we click on next. Okay, so it's not load just yet. Okay, review the settings and click on begin load to load the data. Settings are summary get coded to 1000 default, operator default, time for just a colon space, time default, month, minus DD, default, time, month, DD, HH, month, second, default, string delimited, default. Let's keep going. Option maximum no row, let's go. Load this thing. Okay, let's keep going. Okay, while it's loading, let's look at the next instruction. Okay, because this is a speedrun, guys. This is speedrun. Okay, if the data is successfully loaded, you get a message on the screen indicating the number of rows that have been loaded. Okay, so we're gonna load some rows. Okay, let's keep going. Connect Cognos to DB2. Go to the myibm.ibm, log in with your launch Cognos Analytics. Okay, let's see. Where's my cog? I already have launch cog though. Okay, let's launch this cog. I think we only need this cog. Okay, let's leave this one on the bench. With my well, who belongs on the bench? Jack Grealish. Yeah, let's leave Jack Grealish on the bench there. Okay, let's keep going here. There we go. All right, let's keep going. Hang on. Where's the? Okay, so this is loaded successfully. Okay, so no errors. That looks good. Looks very good. So, what do we want from this now? What do we want? How the time has flown, right? We're studying since like 9, right? How the time has flown? How many hours? Well, it could give the correct number. Oh wow, actually 4 hours. Wow, look at that, 4 hours. That's insane. You did 4 hours? Well, we've been here for 4 hours, guys. That's crazy. Wait, 4 hours 27 as well. That's crazy. Well, it's okay, but we need more hours. Yeah, usually I do more hours than this, so obviously we are going to do more. So let's keep going. So this is loaded. I don't want to load more data. I don't want to view the table because I'm not being asked to. Okay. This is not loaded. This is loaded. This is here. Okay, good. Manage. As far as I remember, I'm just doing it from the video now. Now we want our data server connections. Am I allowed to do this? Can I add one? Let me add one. Is the way the company already added? There's one from IBM DB2. I don't have the DB2 warehouse. I just like to make that very clear. Okay, so here's my okay, so let me do the JDBC. Okay, where's my credentials? Let me get my credentials, guys. So where's the credentials? As far as I know, I need my user. Oh wait, I can get the JDBC. Here's JDBC. I think this is the whole JDBC. It looks like it. I'm not actually sure, to be fair. I think it's it. I mean, it might be wrong, but looks pretty legit to me. Looks pretty legit to me. Okay, so the driver I don't know, but yeah, I don't know. I feel like this is it, right? It just looks too OP, right? It does look too OP. Let me get my host name and stuff. Wait, it gives me the host name. Wait, autogens? Okay, it autogens. User ID. Where is it? User ID. Oh, hang on. Am I meant to cover these? Or who do you think I am? Do you think I'm Anya Kubo? Relax, guys. Relax. I do it real time for you guys. Real time. Okay, so we want user. Okay, user ID, password. What is the password? This is the password. Okay, this password. There it is. Let's keep going. All right, there's the password. Everything looks legit. Everything looks awesome. I don't know what's going on here. Do I click restore? Okay, if I lose it, I'll be pissed. Okay, it didn't. It worked. Okay, I don't know what's going on there. Prompt for the user ID and password. Connect anonymously. Okay, this is where I ask for help. This is where I ask for help, right? This is where I ask for help. Oh, you want me to test it? Oh, okay, I'll test it. Hang on. Let me test it. Okay, testing failed. Is there meant to be a semicolon? Wait. I think it might be a semicolon. I think that might be the problem. Hang on, let me put this here. I think it might be a semicolon. Let's put a semicolon there. Let's try a test with a semicolon. Maybe that's better. Because that is the same. Okay, now I don't understand. Oh, I see what they... Oh, wait. Oh, they did say move the angle brackets. Well, the thing is, it's not angle brackets for me. It's for... it's less than and greater signs. But I guess angle brackets, you can see that as well. Alright, so... Should I test again? I think... Okay, so might be test failed. Okay, success. Okay, that's fine. Alright, let's just leave it at that, right? Okay, so test is success. If the test is succeeded and Congress managed to connect the DB2 instance, you'll say, okay, so click on the pencil icon to give the connection name. Give the connection name my DB2. Where's the pencil? Let's call it my DB2. Does that look right to you? Does it look right to you guys? Okay, it looks a little bit funny because it doesn't match. Okay, DB2, my DB2. That looks fine, right? Alright, there we go. That looks okay. Alright, pretty good, pretty good. Alright, do I say, they say click save, right? Okay, success, click save. Alright, let's keep going. Go to the schema and click on, oh, they didn't say that? Oh, they didn't say that. Oh, wait, no, it's not. Like, choose load metadata from the table that appears. Okay, where is it? There it is. Okay, so we've saved it. Go to schemas. Okay, so we're at our schemas page. Okay, so schemas. Choose load metadata. Okay, so this we know, right? How do we find my schema? Oh, we want to find my table. So where's my table? My DB2. Does anyone see it? So... Whoa, what is going on here? Go to the schema and click on next to the schema name. Oh, you mean my schema name? Oh yeah, that's a bit obvious, isn't it? That is my schema name, by the way. Alright, so let's go here. Let's load some metadata. Yeah. Load metadata. Okay, we're loading some metadata. What metadata are we loading exactly? Oh, we're loading the metadata from that schema. Okay, that makes sense. Okay, once the metadata is loaded, you'll see a green check mark. I don't see any green check mark next to the schema name. I'm assuming it is done. It says it was modified at 7:35 a.m. Of 5 connections. Connection refused. Are there other people connecting to my schema? That's how many people are watching the stream? Wait. How many people are watching the stream? This might be a problem. Surely no one's watching, right? It says there's one person watching. Okay, that's good enough for me. No one's watching, so that's good. That's good. That's what we want. Wow. So we actually got something wrong. Okay, let's go back to manage. Let's go to my DB2. And I'm gonna go to schemas and advanced. Maybe is that where I get schemas from? Okay, so I don't get advanced connections. Where are these connections? Okay, there's my connections. Yeah, let's go to this one, I guess. So schemas, we have schemas. Why are there 5 connections? There's 5 connections? There's 5 connections? What? How are there 5 connections? Who's trying to connect to this thing? So this is why you don't give off your details, right? So people are actually using this. That's hilarious. But again, they probably don't know how to use it. Connection refused. Oh, okay. That's fine. We will just have to create a new credentials. We could create a new instance, but we could actually. Let's create a new instance. Why not? Let us create a new instance. All right, so let's create a new instance. I am going to remove this service, and we will continue with a new one. I think we might have a problem, and we might have a slight problem if these tables are not like saved. If they need it in the assignments, then we'll have to redo some stuff, which would be annoying. So hopefully we don't have to redo any tables. Yeah, I have to delete this, guys. I'm sorry. You guys are all using it. It's too many connections. So let's try again. Let's create. Let's find the DB2. Yeah, people just keep using it. I can't help it. I wish I could cover it, like, but I know no one watches this thing. That's the thing. It's just a bit weird. Like, you really want to screw with me that much? Alright, I'll go ahead. Try and screw with me now. Try and screw with me now, guys. Try and screw with me now. Alright, service created. Alright, excellent. Now it's working. We could obviously just run all the queries again, but okay, we gotta wait for it to provision. And then we can access it. Alright. Someone hacked my account, exactly. Someone hacked my account, exactly. Alright, let's refresh. Hopefully it's worked. We'll have some new credentials, and we'll have to use them. Unfortunately, this is the life of a streamer, guys. This is the life of a streamer. This is a life of the streamer. Provision in progress. There's not much I can do here. I suppose I could answer the questions for the end for the whole week. So why not? Why not answer some questions for the week? All right. So we have some the week questions. These are as follows. Where are the week questions? Here they are. Learning objective questions are as follows. Question 1. Describe a general data warehousing architecture and its component layers, and distinguish between general and reference data warehouse architecture. Well, we should have some notes on that. So we have, oh wait, this is not even true. We have lots of things we need to go over. So data warehouse architecture. List use cases of data design considerations. Considerations would include report generation, dashboarding, exploratory analysis, automation, and machine learning, and self-serve analytics. All right. Let's see. So that is question 1 done. We can mark that off for data warehouse architecture. Let's continue. Question 2. Describe general data warehousing architecture and its component layers. Architecture. This is for architecture of EDL companies that go to analytics requirements include the following components: data sources, for example, flat files, databases, and existing operational sources. ETL layer for extracting, loading, and transforming data. Optional staging sandbox areas. Data lakes, for example. Holding data and developing workflows. Enterprise data web repository. And let's just hang on, wait, let me just see if it's loaded. Are we good? Are we good with this? All right, we're good. Let's go. Yeah, the goal is just to finish the lab. That's all. Like, I get it, there's people who want to be idiots. I mean, I get it, there's people who you know, want attention. Oh wait, what's the actual term for that? There's people who want to like log into the account and like give me attention. I appreciate the attention you're giving me. Like, I love that you're giving me so much attention, but maybe pay me a little bit less attention. Maybe just pay me a little bit less attention, dude. Just pay me a little bit less attention. Thank you so much for the attention. Thank you so much for the attention. But please, just pay me a little bit less attention. I greatly appreciate it. I greatly appreciate it. All right, so we've got our JB. We got our new one here. Yeah, we're gonna create a chilled new one here. Where's my thing? Let me remove this. Okay, so no one can use it. Okay, so we're gonna create a new one. Is it gone? Wait, why is it still here? Delete. Okay, it's gone. All right, now we're gonna create a new one. IBM DB2 and do. So schema says something's wrong there. Okay, so let's go here. Let's go. Where is JDBC? Let's go here. Control C, Control V, and let's go here. I mean, I'm not surprised this happened, by the way. Yeah, I'm not surprised at all that this happened. Oops. I'm not surprised at all that this happened. Hang on, what just happened? Oh no, did I just mess up everything? Come on, guys. Come on, guys. Come on. Come on, guys. You guys want to give me this much attention? I really appreciate it, though. I really appreciate all the attention you're giving me. Thank you so much for the attention. Thank you so much for the attention. I appreciate the attention. Thank you for the attention. Keep giving me the attention. I love it. I love the attention. Okay, let's see. Your password. You want to give me some more attention, guys? You want to give me some more attention? Thank you. Thank you for paying me so much attention. Thank you. Thank you. But really, I don't need it. I really don't need it. I really don't need all your attention. But thank you for your attention. Thank you so much for your attention. That's the password. Okay, so we're good. This should work. Let's test it. All right, success. Let's save it, I think. Oh wait, we need to make some things. We need to change the name first of all, I think. The name needs to be changed to my DB2. I like that. My DB2. That seems pretty chill. So let's save it. Now we need to put some schemas into it, I think. Some chill schemas, guys. Let's do some chill schemas. Oh, wait, what am I doing? Oh, am I just insane? Oh, am I just insane? I'm just insane, aren't I? I'm just insane. Oh my word, I'm actually insane. I actually need to create that table. Wait, let me get that table. Let me get that. Okay, let me just load that table quickly. Let me just load that table quickly. Let me just load that table quickly. Yeah, then we can start, you know, do like 100% completion. Like we want 100% completion. We want to clock the game, as they say in South Africa. What is it? Tables, load data. Oh, sorry, what am I doing? Load data. So poor. Browse files. Where's the file? Let's find the file. Cloud billing data set. Let's go next. Let's go schema. This is my schema. Okay, this. And we need to create a new table called, what is it called? It is called billing. Oh wait, we need to get here. Bit higher. Okay, quite a lot higher. Billing data. All right, let's continue. Billing I love that you guys give me so much attention. Yeah, you know, I really love that you guys give me so much attention. I really appreciate it. Thank you so much. So you wanna log into my account? I love that. That's the fans. You know, that's the true fans. That's the true fans. Shout out to you guys. All right, keep doing it. Keep doing it. It makes me feel so good. It makes me feel so good. All right, let's see. Billing data. Create. Let's create billing data. I think create billing data. And then with billing data, we want to load some data. So we go next. Now for country, we change it to varchar 30. Varchar 30, and then to month. Wait, what's going on here, guys? What's going on? What's going on here, guys? 7. Yeah, it's simple. You just block some people. It's easy to find those people who use those. It's easy to find. I mean, you've seen what I. It's easy. It's easy. It's easy. It's easy to find those people who did that. It's easy to find those people. It's so easy. So easy. So easy. This is mine, right? This is mine. Hang on, where's my? No, I'm taking a risk. Yeah, okay. This is mine. Let's go here. Wait, let me just make sure it's loaded. Okay, it's loaded. Let's go here. Let's go here. And let's load metadata. Now let's see if you guys can connect to it in time. All right, let's see. 14%. Oh, you guys have got very little time. Maybe I wonder if 43%, 71. It's GG's, guys. It's GG's. I win this time. I win. You can't connect to my database. You guys can't connect to my database in time. Sorry, guys. You lose this time. Sorry about that, guys. Sorry. I wish I you know, I was hoping you'd win. In the end, I win. I always win. All right, let's keep going. Where is this thing? Save, close the schema, put metadata. Okay, we did this. This is loaded. Okay, so it's task 3, create data module in Cognos. So now we want to go to our Cognos, and we want to go to new, and we want to go to new data module. Now let's see what comes up. So we say new data module. Click the data service icon and choose the MyDB2 connection that was created in the previous task. So team content, this must be servers, right? Data servers and schemas. Go to MyDB2. Click on MyDB2. Okay, now and the previous task. Okay, choose the schema from where you want to load the data. Okay, this is our schema that we want to load the data from, right? Okay, it looks like it's loading. Choose the select tables option and click OK. Did I screw up, guys? Oh no, did I screw up? Oh no, so hopefully I didn't screw up there, guys. Wait, did I? Okay, I don't see the select tables option. Is there something I'm not seeing here, guys? No, it's fine. Okay, choose the select tables option and click OK. Now, where is can't believe you guys did that. That's crazy. So let's choose the select tables option and click OK. Click add tables, and you can specify how to. Okay, well, what am I doing? Just click and select. Oh, wait, did I just do something wrong? Can I go back? Oh, I need to go back. I feel like I need to go back. No, it's fine. What is going on? Go forward. Oh boy, this is not going well. In this table, we'll use the billing data. Choose the table. Okay, billing data. Is that fine? I don't know. And for this table, we'll be using, for this lab, we will be using We'll use the billing data table. Choose the table and click on OK. If you want to view the data, you may click on refresh. Okay, fair enough. In the data module loaded with the data data module loaded with the data appears. Click on save once you see that the data is correctly loaded. Is it correctly? It does look correctly loaded though. So let's click save. What do you want to call it? With an appropriate name. Okay, so what do we want to call it? Billing data. I don't know. I'm gonna say billing data. I'm not actually sure. Billing data. Is it a schema? I don't know. Billing data. I'm just gonna call it billing data, right? I'm just gonna call it billing data, right? Okay, let's keep going. Let's call it billing data. Let's keep going. Billing data. All right. So we got billing data. Let's keep going. So we got billing data. Looks pretty reasonable. Let's keep going. You can now save an appropriate name. Oh, they said billing data module. Okay, surely mine's fine though. Do you want me to say module, guys? Should I say module for fans? For all the guys that keeps hacking everything of all my accounts. It's for you guys. All right, let's keep going. Let's keep going. All right, create a dashboard. From the IBM Cognos menu, choose New and click on Dashboard. Choose the tab as shown in the following. Okay, so wait. We're going to go to New. Okay, we're going to go back to New again. We're going to say Dashboard. All right, let's keep going. So click on Dashboard. Choose the tabbed option as the following. Choose the tab as shown in the following image. What are you talking about? I don't even know what they mean here. Choose the tab as shown in the image. Oh, okay. Click on select source to choose the source for your template. Okay, so I'm going to choose tabbed and I'm just going to say this. Wait, what? What do you mean? What's going on? I don't know what's going on here. And okay, I know I have to say select source, right? And I've watched the video. So where's the thing? Okay, so select from the list, choose the data module we just created and click add. What is the one we just created? I have no idea. What is the one we just created? Is this it? Oh, sorry, obviously, yeah. So it's in my content, select source, my content. The one we created was billing data module. I created two, but I think billing data module is the one we want. Not sure. Okay, anyway. Now, what do we do? Visualization. This is actually in the 5 steps. I mean, this is like some bonus content, you know. Some extra XP for you guys. Here are the steps. The first step is identify the database schemas, tables, and connections credentials, which we did with some effort, unfortunately. Step 2, create server connections. Step 3, create modules to the selected tables. Step 4, create a dashboard and add data modules to it. Step 5, create visualizations. Drag columns from the data module onto the dashboard. Let's keep going. You will now see the table listed on the left panel with all the attributes. Okay, I must remember to do the dish. Okay, what must I remember after I'm done with this? Do the dishes. Do that. Do the dishes, do that. Make supper. Cut the onion. Prepare the ava. Okay, I've got it. Task 5, visualization. You will now see the table listed on the left panel with all the attributes. Drag and drop the build amount on the template. Okay, well, I think this is like the whole template, right? Am I crazy, guys, or is this the whole template? Okay, I know I chose it, right? Okay, the total build amount will now appear on the dashboard. The size and position can be adjusted as per requirement, and the text display can be edited and formatted by double-clicking on it. Okay. Oh, I didn't know you could do that. I didn't know about double-clicking. Is it just double-click? Wait, double-click? Double click. Okay, well they lied. Double click does nothing, but it does do this. You can sum. Oh, this one you actually can. Okay, this one actually has average, but I don't know why the other one didn't. Maybe it was a mistake from me. Probably it was. Always bit. Okay, drag and drop build amount and industry, and onto the dashboard as shown in the following image. With this, we can visualize the build amount per industry: 1.32 billion. Okay, so this is per drag and drop the build amount and industry onto the dashboard as shown. Oh, drag and drop build amount and industry onto the dashboard as shown in the following image. Okay, so we want build amount. Can't do that. Okay, it's not up to nonsense. So build amount and category. Is this category or what is it? Category? No, sorry. It's build amount and industry. It's industry. So industry. There we go. Okay, so build amount and industry. Let's just pop it over here. I mean, they put it somewhere else, I guess, but I mean, I'll just pop it over here. All right, maybe I'll move it. Why don't they move it, guys? So it looks like their image. That's what they want, right? Let's make it so it looks like their image. No, okay, this is annoying. Anyway, that's what they wanted, so let's keep going. Okay, so that'll be there. Drag and drop the build amount, country and industry onto the dashboard as shown below. This will generate a heat map of spending by country and by industry. So heat map, okay. Okay, so I can't really remember what a heat map is actually, to be fair, but I can't actually remember what it was. Can't remember what a heat map is. Okay, building data, industry. Oh, what am I doing? This is so bad. This is. I know one of them is industry. I know one of them is build amount, but I don't know what the next one is. A category? No, it's country. Okay, so country. Pretty chilled. Okay, so this goes to the right. All right, there we go. So I think we're not using all the space, to be fair. So yeah, I think I can fix it. There it is. I can just go here. They want one more. Or am I just crazy? Let's go here. All right, this is pretty good, right? Who cares about the stupid placement of these things? Do you know how much effort goes into making it? As data scientists. But anyway, the finished dashboard will appear as in the following image. It doesn't? I don't think it does. Oh, it does. Wait, let me just make it look the same for all of the fans. Wait, sorry. Let me just make sure it looks all the same. It's going to be a big heat map. Okay, here we go. Can you guys see it? Looks better, right? Wait, sorry. Wait, why does it look so... Okay, there we go. So this does actually look the same. Okay, good. Optionally, try to change the properties and settings to see how the dashboard changes. You can also observe the build amount changing as you click on a region on the heat map or bar graph. And we have Levan TS. I think that person is a woman. She created it. Oh wait, so this is a strange change log, but anyway, let's keep going. So let's mark this as complete. Go to the next item. Now we have a few things to go over, guys. Oh, summary and highlights. Must I do summary and highlights? Again, I think they know themselves that the summary and highlights are a bit bizarre. Yeah, it's the same. It's just the same process. It's just you just gotta remember how to do it. That's all. You just gotta know how to do it. Well, which I do know, which is good. Okay, so all right, let's do the summary and highlights. This is a speedrun, guys, after all. Yeah, I do want to go into the final assignment, but of course, I'm sure if any of you are like loyal fans and have watched from the beginning, which I'm sure all of you are, then you'll know that, okay, summary and highlights. Okay, summary and highlights. Yeah, then you'll, okay, I'm not going to get back to that. I'm just going to get focused. Summary and highlights. Okay, analytics is the building of data models to make better decisions, and business intelligence is a technology. Okay, let's just write it out. Analytics is the building of data models. Is the building of data models to make better decisions. And business intelligence is a technology that enables data preparation, data mining, and data visualization. Let's keep going. Accessing a database. Accessing a database requires what is it? Accessing a database in Cognos. Accessing a database in Cognos requires a data server connection. It requires a data server connection, and it requires a data module. Okay, let's keep going. There's one more point here. Oh no, there's more. A data module. Okay, that's that. Thank you guys. And sorry, I meant to read that. Sorry, you also learned how to add a data module to a dashboard and add its fields and columns to create visualizations. You gain practical hands-on experience with IBM Cognos Analytics to create dashboards and visualizations. Should we write it out? I don't know. Maybe we should look at it because it's like the highlights of the show, right? It's the highlights of the show. So maybe it's like for like a clip or like something. You might want that. So let's get that. Okay. So you also learn. Now let me just write it down. Dashboard uses fields. We learned, not you. We learned that we learned how to add a data module and to a dashboard and use its fields and column and use its fields and columns to create visualizations. All right, guys, let's keep going. And we gained practical hands-on experience with Cognos Analytics. To create Cognos Analytics to create dashboards and visualizations. Okay, so a lot of visualizations there, guys. Okay, so let's see. Course 9, week 3, module 1. I actually wish I had. Okay, let me fix this. Because I'm feeling like we're gonna have to go into course 9, week 4, module 1, which is completely different. To create dashboards and visualizations. and visualizations. Let's keep going. So, okay, wait. Let me just put this. Let me just draw a line at the bottom of the page. Okay, there we go. Okay, good. Let's keep going. Now I think you can't say we're done with this week, but we can definitely. Oh wait, let me just. What is it? Teabag this thing? Is that what they call? Let me just teabag this. All right, let's teabag it. All right, or hedge, or like, or like, what's it? What's a no look a no look headshot or something? I think I should. I'm just gonna save your dashboard. Let's call it my DB because then I will know what it is. Okay, let's call it this. Always put it in. Always okay. My content. Put it. Okay, my content. My content works. Okay. I need to just hang on, guys. Yeah, well, are we still streaming? Are we still live? Let's see. We're still live. Let's keep going. Of course, we're still live. Let's keep going. Alright. I think this might be the longest stream if we make it till 6. Unlikely. Well, I hope. Well, maybe it's likely. Hopefully, that's the goal, guys, to make it to 6. All right, let's go to. Oh yeah, that's how our goal is to now simply go over the learning objectives and finish both of the other modules. So we had module course 9, week 2. We had week 2 that we wanted to complete, and this was week 3. So this is week 2. As far as I know, this is week 3. Okay, so this is week 2. Let's go over week 2 quickly. Okay, so describe general and... Okay, it is right? We're in week 3. That was week 2. Okay. Alright, I'm not losing my mind here, guys, am I? Yeah, this is week 3. Okay. Describe general data warehousing architectures and its component layers. Okay, so let's do that. Architectures for the enterprise data warehousing companies adapt for analytics requirements. Components of an enterprise database warehouse. Enterprise data warehouse. Data sources, example flat files, databases, operational sources, an ETL layer for extracting, loading, and transforming data, optional staging, sandbox areas, data lakes for holding data, and developing workflows. Enterprise data repository, sometimes data marts known as data marts, which is known as the hub and spoke. Okay. Analytics layer for BI analytics tools. Enforce security on incoming data. All right, so that is question 2 done for data warehouse architecture. Oh, there's more. Oh wait, this is the diagram. So the diagram of EW architecture, you have your data sources, then that goes into the staging sandbox area, which contains the extract, transform, and load process. And you have your enterprise data warehouse repository, which contains your metadata, your summary data, and your raw data, which goes into the data marts and then goes into the analytics and BI tools. Okay, so I think that does answer us. So next question is question 3. Distinguish between general and reference enterprise data warehouse architecture. So reference enterprise data warehouse architecture is an adaptation of general enterprise data database warehouse architecture. Basically, it creates a template for data warehousing solutions. And a reference enterprise data warehousing architecture has many components and requires interoperability, and many tools and integrations are used. General architecture has less components and less required interoperability. Question 3 is done. Let's move on to the next question 4. Question 4. Describe the reference architecture for two enterprise data warehouse and warehouse platforms and business intelligence platforms. Okay, so IBM reference architecture diagram, you have your data acquisition, which comes from the data comes into, for example, HR, human resources, payroll schema, or billing.erp schema, or order payment. Then these all could go into the for the data integration phase, into the extraction process, into the staging area, and the warehouse, which has the administration tool, and the trunk, and then it goes into the arrow into transform and load, then arrow into and back and forth control metadata. Next, arrow goes into the next phase, which is data repository, which goes into analytics, which data repository. Then it goes into analytics and the presentation layer finally. So we have data acquisition layer, data integration layer, data repository, data store, that's the storage layer, analytics layer, and presentation layer. See, there's more. There's more. Components of IBM specific reference enterprise data warehouses include data acquisition layer, human resources payment, which is payment, billing, and finance, and you can also have the integration layer, the enterprise extract, transform, load, plus staging. You also have your central data regional layer. Staging is relational analytical layer, and which is in a cube format because the cube is the best. Final presentation layer incorporates multiple users. And let's continue. Is there any more? Yes, there's a lot more. Oh, is it? Oh, yes, and there's some Easter eggs, some side quests here. These are the different platforms that can use it, which is architecture that can use it. For example, IBM InfoSphere Data Stage. It's reference new real-time integration of all data types on-premise and in cloud. Okay. Now we have the IBM InfoSphere metadata, which is end-to-end data flow reporting and impacts analysis of information assets in an environment. InfoSphere quality stage, where this is also data quality and information governance, investigate and clean and manage your data, create consistent views of entities, customers, vendors, locations, and products. The IBM DB2 warehouse products that are highly performant, scalable, reliable data. Products can manage unstructured data, structured data, and products can also be on-premise or on the cloud. That is for the IBM DB2 warehouse. IBM Cognos Analytics involves advanced business intelligence. It is an advanced business intelligence platform. It generates reports, scorecards, and dashboards. It also can be used for exploratory analysis, curates data, and joins data from multiple sources. And yeah, that's question 4. Question 4 is done. Let's move on to the next. What is it? The next item, I think it was, or the next video. I'm not sure. The next item or next lecture. Next lecture. Okay, next lecture is as follows. It's about cubes, rollups, and materialized views, and tables. So, questions and learning objectives. Question 1: relate what a data cube is in terms of a star schema. Discuss the terms slice, dice, drill up or down, roll up, and pivot in terms of data cubes. Describe what a materialized view is. Recall 2 use cases of material. Let's get to question 1. Question 1: relate what a data cube is in terms of the star schema. All right. So a data cube is all about online analytical processing. It is a cell in the cube. Every cell in the cube represents facts with dimensions and has coordinates which are dimensions. Cube operations include slicing, dicing, roll-up, drilling up and down, and pivoting. For example, the dimensions may be year in the cube, product in the cube, and rate. These are all different dimensions on the cube. And in the facts in the cube represent facts. Okay. You can also slice data. Oh, sorry. That's question 1 done. Question 1 is done for cubes, roll-ups, and materialized views and tables. All right, let's continue. Question 2. Discuss the terms slice, dice, drill up or down, roll up, and pivot in terms of data cubes. All right, let's continue. So slicing data cubes involves, what do we do here? So it's like, think of it like a tomato. Or not a tomato, a block of cheese. Okay, so let's see. Slicing reduces the cube dimensions by 1. So if you, I could show you with the video, but I don't really care about your knowledge. You're just here for the ride. Okay. Dicing data cubes, 2018, 2019, 2020. Could be blocks in the cube for a year. Then you can have different types of products with the product dimension. Select only gives shortened genes from product dimension. Dicing shrinks a dimension. It shrinks a dimension, however, it does appear that all the years are still there. This one, all the years are not there for slicing. Okay, so drilling down into data cubes, you can drill down with hats and gloves. You have Ohio, Iowa, and Utah as all the states. Drilling into subcategories of subcategories of dimensions. Is dimension an index slim fit, for example? Oh wait, guys, let's show you guys how much work we've done today. It should be pretty decent. How have we done? We've done pretty good. 5 hours is pretty good. We have to subtract maybe 1 minute here and 36 seconds here, but that's not bad. That still gives us for 5 hours, so pretty good. 5 hours studying, not bad. How much more can we get if we can get maybe if we can get 2.5 hours in, I think we get 7. I think that's pretty good as well. All right, so dicing data cubes. Dicing shrinks a dimension. So drilling down into the cubes does the following. You can basically go into a more detailed view of one of the products. For example, t-shirts, classic, slim fit, relative fit. Drills into subcategories of dimensions. Is dimensions an index? For example, slim fit. Drill up is the opposite back to original. Drill up is the opposite, goes back to original data and dimensions. Okay. Question 2. So more of question 2 here. Pivoting a data cube. When a data cube is pivoted, all its dimensions are interchanged. For example, years and products, as you can see, or as I can see here. Switch to the product. Okay, rolling up. Okay, so rolling up and data cubes. Summarize dimensions. Aggregate using count, min, max, average, sum. So this sort of rolls it up and aggregates, as they say, summarize exactly. Okay, so question 2 is done. Let's keep going. Question 2. Where's question 2? Okay, it's question 2. Highlight it. All right, question 2. So we're on question 3. What's question 3? Question 3. Describe what a materialized view is. Okay, so a materialized view is a read-only snapshot containing results of a query. It is used to replicate data in a staging area. It automatically keeps query results synced to a database. It can safely work with data affecting the source database without affecting the source database. You can set up different refresh options for a materialized view. Never I guess, upon request manually, immediately, or automatically. So automatically, immediately, upon request manually, and never. Those are the different options for when you refresh your materialized view. Let's continue. More of question 4 here. Oh, sorry, no, this is question 3. Question 3, we just learned about our materialized view. So we just learned about it there, guys. We're just chilling. We're just chilling. We're just chilling. Oh yeah, I mustn't let the screen cut out because I think we lose it. Here, okay. Question 4. Recall 2 use cases for materialized views. Here we go. So, materialized view in Oracle. In Oracle, you can create a materialized view in Oracle. Create a materialized view, capitals create a materialized view, my_mat_view. Next line, refresh fast, refresh space fast space start space with space sysdate. Next line, next sysdate +1. Next sysdate space plus space 1 as select from my_table name. Okay. Oh, so this is just the name of your table. Okay, so this is in DB2. We sort of know this, right? Okay. Create materialized view object called materialized view. The specify rate which incrementally updates the data. Specify the refresh rate as fast. Specify the start. I must write neater actually, so because when I have to read this stuff. Okay, specify the start date for the refreshing data increment. Now, I've said this before. Increment sysdate today from today. Step. Wow, what is going on here? Step 1, 2, 3, 4, 5, 6. Step 6. Sysdate materialized view. Every single final statement is select from my date. Okay. I have no idea what they're talking about here, but I definitely understand the code. And it sort of does tell you when it refreshes, right? Okay, materialized view in PostgreSQL. Create a materialized view in PostgreSQL. Oh, that was Oracle. Create a materialized view, my_mat_view. What is that? Not curly brackets with curl okay, I've actually okay, brackets with bracket storage parameter. I need to get this right. I can't remember what that was. Array brackets with what is it? With what are the other brackets? Tuple, yeah. Array brackets with tuple with open array brackets with open tuple brackets, storage underscore parameter, open array brackets equal value, close array brackets, open array brackets, comma, close array brackets, close tuple brackets, close array brackets, open next line, open array brackets, table space space table space underscore name, close array brackets, next line as select, or list brackets to be honest. Okay, as select star from table name. Alright, so that is your materialized view in that. In PostgreSQL, you can only refresh materialized manually using refresh material view. To do with the next right hand, okay, materialized view in DB2, okay, keep going. Materialized views in DB2, step 1, create table, select employee first name, employee last name. I think we've done, okay, where as department from, okay, as, isn't it as select, or am I mad? Yeah, it is as select, and yeah, okay. Initially deferred, refresh immediately. Talk employees, employee departments talk to sequence initially refreshed. Those immediately checked means that the data is checked with the query and then it is loaded into the database. Data not incremental means the data integrity once changed the database is reflected to another query executed against another materialized query and it shows the database with data. Okay, so I assume deferred refresh immediately means refreshes immediately. Okay, question 4, unfortunately, very unclear, but it is done. That one is a bit unclear, unfortunately. Okay, question 4. Next one. Next item. Grouping. Oh, is this? Okay, no, this is an article. Facts and dimensional modeling. Questions or learning objectives. Question 1. Define a fact. Facts are either qualitative, image, visually, or quantitative, number of sales, millimeters or rain, temperature, values, columns in a table. Example, weather feed icons, location, and date. Okay, that is question 1 done. Define a fact table. A fact table is a foreign key which links to dimension tables like store ID. Detailed information on a facts aggregate, for example, group. Generally, business processes or transactions. Okay, is that question 2? Okay, there's more. Okay, a fact table is a snapshot of fact tables. Record events in a database in a well-defined way. Order ID, order amount, order date, amount paid, date paid, bill date, start date, bill date, end date, ship date. You can have them in. Okay, there's that in order. That diagram. Sorry, order ID, order. Okay, that's too late. Let's keep going. Question 2. Let's move on to question 3. Define a dimension. Dimension is a table that is a dimension of a fact. You can aggregate dimensions for business questions or in aiding decisions. For example, filtering, grouping, labeling, people or product, also known as a categorical ID or variables. Okay, also known as categories, I guess. So, excuse me. All right. Question 4 is as follows. Define a dimension table. Dimension tables contains facts, tables, and dimensions. Example of a dimension table is a product table, make, model, color, size, employee table, name, departments, temperature table, date, time, generating of events, geography table, country, state, city, region. There we go. That's question 4. Question 4 is done. So question 5, describe an example of a fact and examples of fact and dimension tables. Example schema of a fact and dimension table would be a dimension table of vehicle, make, model, dimensions. Let's do that. So question 1, stars keys, and that's keys are the edges, and you have a fact table, key, line, edge. Keys or edges relation to connect fact tables to dimensions. Consists of multiple foreign keys that relate to tables. Snowflake is snowflake schema is in the dimension tables that have dimension tables are split and split tables. Snowflake shape. Okay, dimension tables are split on split shape. Star used for data marts. Dimensions radiate a central fact. Edges are relations. Keys between facts and dimensions. Star normalize. When you normalize it, goes into a snowflake. Snowflake, normalize arrow snowflake. All right, let's continue. Is there anything more? Is this still question 1? This is still question 1. Oh, this is all of them. Okay, okay. Modeling terms of facts and dimensions. I think that's done. Describe a snowflake as extension of a star schema. Okay, I guess we just got to continue. So modeling with a star schema. So this is all of those 3. So describe snowflake schema as an extension of the star schema. Distinguish questions. That's question 2. Question 3. Distinguish star schema from snowflake schema in terms of normalization. So modeling with a star schema, design considerations include you select a business process, choose a level of detail, identify the dimensions, identify the facts. Example model: want to develop data plan where you collect the point of sale transactions. Then number 2. Then you want to understand level of detail, granularity, which is the receipt, the ages that include date of time or purchase. Identify the step 3. Identify the to set dimensions, which will include, okay, 3. Next line is to identify the dimensions, which will include date and have the time dimension. You might add other dimensions such as payment method. These will be fact tables contained inside a dimension. Next section, which is 1, 2, 3, 4, 5, 6 lines, labeled 4. Then you include the facts, the columns in the table and in the dimension. These facts can be products, make, discounts, quantity, and sales transaction tax. The facts are contained inside the fact table and used inside the dimensions table, which connects it to the star. Snowflake schema is an extension of a star schema. There are many keys in a Snowflake schema that the tables are normalized, duplicate stored and placed in a structure keys create the star or the Snowflake star schema for point of sale. In the fact table, you have your point of sale ID, which is your primary key, your store ID, your foreign key, your date ID, your foreign key, your cashier ID, your foreign key, and your product ID, which is your foreign key. Dimension has your product, the next one which goes out, your key or your edge, contains your product ID, and your product table, and it has product ID. Cashier table, which has your cashier ID. Member table, which has member ID, which also links to it, and your dimension, which is a dimension, and you also have another dimension table, and another dimension table with a date dimension table, which has date ID, which goes to the fact table, which has all the foreign keys which relate to it. Okay, fact tables contains all the facts you need to look at. Okay, I need to write so much NITA so I can read these things, because I have to look back at it. It will go under review. To look at either in your table, in your data mart, or with your BI analytic insurance. Dimensions are connected to the fact table with keys. A lot of primary keys and foreign keys. Using additional keys, you can create a data for example, for a city, you might create a country or a dimension table. Okay, so that is it. Don't ask me how that answers these 3 questions, but that answers the questions of describe the star schema. Is modeling in terms of facts and dimensions. Describe star Snowflake. Whoa, my mouse just got blue. All right. Describe. Oh, is the OBS cut out? Okay, whatever. Should I check? I don't care. I really don't care. Okay, describe star schema modeling in terms of facts and dimensions. Question 2, describe the Snowflake schema as an extension of a star schema. Distinguish the star from Snowflake schema in terms of normalization. More tables. Okay, that's that. So let's see. I think this is very close to being the last one. Alright. Is this the last one, guys? Is this the last one? Why does this feel like it's not the last one? Oh wait, this is far from the last one. Wow, this is brutal. Excuse me. Describe what a data warehouse staging areas for data warehouses, questions of learning objectives. Describe what a stage. Okay, yeah, for the last one we were looking at the data modeling with star and Snowflake schemas. Okay, so staging areas or data warehouses, questions of learning objectives. Question 1. Describe what a data warehouse staging area is. A staging area a data warehouse staging area is a bridge between the data source, where data is extracted, and the data warehouse destination system. Data is stored in a silo in a data warehouse. Data warehouse staging are decoupled from the extraction of data into the system. Transient, meaning it's sending of data to general purpose arrays, which can be erased. It's optional. So, okay. However, the staging area backups it could involve transaction, data warehouse staging events, flat files plus. Oh wait, we could break the record, right? We could break the record, right? We could. Yeah. Has there ever been a South African that streamed for 7 hours on a Sunday? Let's see, maybe. Wait, what am I doing? Are we breaking records here, guys? How long have we been streaming for? How long have we been streaming for? Yeah. 1 hour 55? Is that all? Back. Yo, we've already been streaming. I think we got so 1 hour 55. How would that work? So I get 5. 1 hour 55. So I get 2 hours. So I think we can do 4 hours stream. A 4 hour stream is pretty chill. 4 hours stream, pretty chill. 4 hour stream. But we want to break the records. I mean, if it hadn't cut out, we have 7 hours. So a bit disappointed. Okay, describe what a data warehouse staging area is. Okay, so data warehouse. Okay, we've looked at that. Data bridge between the data source destination silo and the warehouse data station sizes and transit matrix and operates turn. It can be troubleshooting turn. Now staging areas involve plat files plus Python, SQL, tables plus DB2, database plus Cognos. You can also have payroll, online analytical transactional processing, sales, online transactional processing, and purchasing, online transactional processing, all going into this, all arrow going into staging database. Okay, payroll going into database, arrow going to database, processing, arrow going into staging database. So then in the staging database arrows going out 3 ways to 3 different conform tables. And these are all in the staging area. The staging data warehouse and the conform tables are both in the staging area and the data warehouse. Staging area and data warehouse. Okay, then conform tables, all arrows, 3 arrows pointing to the single table. And this is accessed with online, online transactional processing accounting going towards the single table. All right, nice. So this must answer question. Oh, well, it answers question. Okay, so it answers question 1 and 2. Question 2 for the module staging areas for data warehouses. Question is literally to describe why the staging area may be used. Wait, what? How does that answer the question? I'm not sure what they mean. Okay, what do you mean? Okay, so let's see. Relate how staging area is used for integrating data sources. Okay, functional data functions of a data warehouse staging area. Question 3 of module staging areas for data warehouses. Question 3 staging data cleaning, removing duplicates, data integration, consolidating data, extracting new data, adjusting, managing new data that is extracted into the silo, aggregating facts with granularity, number of orders per month, per period for week, monthly, scheduling, backup, the staging is not turning out, normalization, enforce consistency, i.e. data integrity. Why use data staging area? For D, couples extraction and transformation phase. You should use a data staging area because it reduces the corruption of data. You should use a data staging area because it easily backs up the data and nothing is lost. You could use the data staging area because it simply simplifies the workflow by acting as a bridge between the data source systems where the data is collected from the same system as the target system. Okay, I've got to say I got it right, Nita. Consciously, I've got to be aware of that next time. This is poor. Okay, moving on. Verify data quality. Questions or learning objectives. This is the lecture we're about to cover. Question 1. Describe what data quality verification is. Data verification includes checking for accuracy. Is the data correct? Completeness. Is there any missing data? Currency. Is the data up to date? Consistency. Is the so bad. Need to write Nita. Are fields consistent? Are they updated at regular intervals? Yes. So question 1, that is data verification, data quality verification. So the next, question 2 in verifying data quality is identify why organizations verify data quality. Question 2, why organizations need to verify the data? Why organizations verifying data quality is important. IBM in 2016 had $3.1 trillion of poor quality data, and it cost them that much. To integrate data easily, have a consistent okay, have to move to the next one. Verified data is easier to leverage for competitive decisions because it is clean, accurate, and consistent. Data is stored readily and is available for statistical analysis. Boost confidence for business decisions. Next, we have question. Oh, that's question 2 of verifying data quality. Now, question 3 of verifying data quality. List examples of data quality concerns. Let's put some full stops here to add some quality to my work. So let's see. So we have accuracy concerns. Accuracy concerns for source and destination records must match. Duplicated records, typos, of a range of values, spelling errors, mass misalignment, and comma interpreted as a. Okay, so this is accuracy, duplicated values, range of error, arranger, mass alignment, commas, that's accuracy. Completeness, as a data is concerned, locating missing values takes time. Avoid and null values, placeholders like 999 or -1. Locating missing data records to system can lead to system failures. Consistency involves inconsistent units, interpreted units, kilograms and pounds, metal, currency units, non-concurrence and standard terms. So that's just consistency. Okay, inconsistent data shows Mr. John Doe. Okay, so data format, month, day, month, year, month, day. YM bullet point YMD space bullet point DMY, and then currency are the names of the people up to date are the address of the individuals that you are recording up to date. Let's keep going. So that is question 3, I think. Question 3 is list examples of data quality concerns. Just remember to do the dishes. Let's keep going. All right, okay, wait. Let me get the question. Question 4, outline a process for managing data quality. Managing data quality diagram. Detect, arrow into capture, detect number 1, arrow into capture, which is number 2, arrow into report, which is number 3, arrow into ingestion, which is number 4, arrow into diagnose, which is number 5, and arrow into correct, which is number 6. Number 1, detect the problem, you see that it is in there. Number 2, capture the information for the data quality problem. Number 3, and then report the problem to the domain experts in the organization. Number 4, then investigate whether it is an upstream error, source, or process. Number 5, figure out what went wrong, what is wrong specifically. Number 6, correct data quality issues. Okay, managing the data quality process. Example, scenario: following issues, data needs to have reloaded. Missing data, duplicate data, out of range value, invalid values. Write SQL queries for these conditions. Create rules for correcting and managing this is number 2, managing these conditions. 3, create a script that runs the validated queries every night. Number 4, automate the script created in step 3 or performance detection and correction process. Number 5, review the automated part and address issues that could not be resolved automatically. And okay, and then I say data quality solutions, IBM Infosphere Server and IBM Data Refinery, information data quality, SAP Data Quality Management, SAP Data Quality, Talent Open Studio for Data Quality, Precisely Spectrum Quality, Microsoft Data Quality Services, Oracle Enterprise Data Quality, Open Refine. IBM Infosphere allows you to understand your data and your relationships, monitor and analyze your data continuously, clean and standardize and match your data, maintain the data lineage, clean your data and monitors your data in a unified environment. Data verification. Okay, there we go. So that is question. What is that? Question 4. Let's keep going. Question 3 wasn't marked. Question 3 wasn't marked. Come on, guys. Question 4. All right, let's move on to populating a data warehouse. Okay, so populating a data warehouse questions or learning objectives. Question 1: describe populating a data warehouse as an ongoing process. That's question 1. So question 1, okay. As an ongoing process, there's an initial. Okay, this is populating a data warehouse. So as an ongoing process, there's an initial load, then an incremental load. Schema change or corruption is rare with schema change. Store location charges will be rare, but transactions table will change frequently. Loading can be done periodically or it can be done incrementally. Fact tables are updated frequently. Dimension tables are updated frequently as well. Okay, this is a bit better in terms of my notes. So okay. Question 2: list the main steps to populate a data warehouse. Tools for data warehouses include the DB2DW you can use to load raw rows, utility which is faster than loading the rows manually, IBM Infosphere data stage. It provides jobs for integrating your data into the data warehouse, Bash, Python, and SQL scripts can be scheduled to run and are run using cron jobs, Apache Kafka for ELT loads, Apache Spark for ETL loads. Main steps to populate data. Okay, so this is Apache Kafka. Main steps to populate a data warehouse. Preparation. This is where you modeling your schema, create your tables, verify data quality. Initial setup. Create data warehouses plus schema. Create relations in tables, create production tables, load the data, what is transformed and cleaned. Ongoing process. So it's preparation, initial setup, ongoing process, ETL pipeline to to remove bad data. Append data weekly or frequently. You need to check for changes in the data. Must meet the schema requirements. Question 2 is done. Let's keep going. Wait, where's this thing? Oh no, I'm on the wrong page. Question 2 is question 2. Okay, next, question 3. What is question 3? Question 3 is list methods for change detection and incremental loading. List methods for change detection and incremental loading. Okay. Timestamps. Change detection involves timestamps when it was written and when it was modified. Brute force checking rows in table with SQL query with SQL query. Track changed or deleted records. All right. Change detection. Excuse me. Okay. Performs archiving of deletion with a script monthly or yearly for data that isn't used or is taking up too much space and it doesn't live up to the value or needed is the space is taking up. Next we have that is question 3. So yeah, manage detection, change detection, populating data warehouse. Question 3. So question 4 is manually create and populate tables for sales star schema. All right, so where is Okay, so create dimensions table. Create table sales.dim sales dimensions dim salesperson. Open brackets salesperson ID space 0 space primary key comma next line SQL person alternate ID space for varchar tuple open 10 close tuple not open not null open space not space null comma next line sales person name space varchar open tuple bracket and then 50 close tuple bracket SQL semicolon insert into dimension table insert into sales.dim salesperson open brackets salesperson alternate ideal salesperson name values 617 go kart Joe. Let's keep going. Parentheses, is that right? Okay, so then we have create relations between. Okay, so create fact table, create table sales.fact order sales transaction ID big space big serials primary key sales ID int space not space null comma sales date key space int comma order class ID dot int space not space null. Next line is comma sales comma space I guess salesperson ID. Sorry, new line salesperson ID in space int space not space null comma new line amount space money close tuple brackets close tuple bracket create relation between fact and authorization table. Okay, so alter space table space sales dot fact order sales new line add space constraint space new line kv underscore auto class ID space foreign space open tuple bracket auto space dot auto class 50 close tuple bracket new line references new line sales auto category auto class ID semicolon populate the sales fact table insert into sales.factor sales open tuple bracket sales ID comma amount comma salesperson ID order class ID comma sales right key comma close bracket values open tuple brackets 1629 and 4. Okay, so that answers question 4. Let's keep going. Question 4. So question 4 is done. Recall the periodic maintenance required to keep your data warehouse running smoothly. Oh, wait, what? Question 5. Oh, recall. Okay, so that's just chill. Okay, so populating data warehouse. What are we missing? Querying the data is the last one. I know that. Yeah, then it's done. Okay, so then it's done. Then we move on to the next week. And then we keep rocking and rolling. To be fair, guys, I think we may call it a day if I do finish the course. Yeah, just because it is Easter Sunday. Or maybe it's not even because it's Easter Sundays. Actually, let's do some Python. Why not? Let's do some Python. Okay, so querying the data. Interpret a star schema ERD and use the schema to set up queries. Oh, we did that, right? And use the schema to set up queries, okay? Create a materialized view by joining tables by the star schema. When you want to create a summary of joining auto sales, you start by running queries against the service star schema. Find different query tables to see what data is best to summarize to turn the materialized view. Your planned actions decide your query's view is staging area to minimize input of database. Reinforce query during off-peak hours. Query fact sales, order sales, secure, select star from sales.fact order sales, limit 10. comma 2 to create materialized view, create materialized view. Okay. Okay. Is that the question 1, right? Oh, so this is question 2. Okay, question 3 is coming up. Let's keep going. Question 3. Where's question 3? Actually, are we close? Should we just leave this? I feel like we'll need it for the assignment, so I'll leave it open. I'll probably get the assignment done today as well. Why not? Maybe then do some Python as well to finish off. Okay, let's actually, no, I'll probably do the next course. Probably just do the next course. I don't know what's up with that. Anyway. Okay, so question 2 is done. Let's move on to question 3. Question 3, apply the cube and roll-up options in a group by clause. Apply the cube and roll-up options in a group by clause. Cube and roll-up provides summary reports, materialized views. Okay, wait, let's go with the question 1. So questions, apply the cube and roll-up options in a group by clause. Cube and roll-up provides summary reports. Materialized views are stored in tables. Querying materialized views can reduce complexity. Materialized views and cube and rollup functions enhance query speed and performance. Also, query results looks more clean. So cube, select columns, and then from table where conditional statement. And you can group by, then you say cube, and then you put brackets. In the brackets, you put in your brackets, you put the columns you want. So there you go. So that is cube. Cube provides a summary of each individual attribute. Cube provides an aggregate for all attributes and for each attribute individually. For example, the salesperson and the amount of sales they have, also the aggregate of the aggregate. Now for rollup, you say select the columns from the table where, if you want to use a where clause, and the group by, then you have to use group by and say rollup. And in the brackets, you say the columns. So rollup rollup does not contain additional columns. The first column is used with some, it's rolled. However, its previous column is now rolled up. Rollup only includes first column in group by group. Okay, they're different. I get it. Okay, question 3 is done. Now I think, are we done? Are we done, guys? Are we done with this one? I might be wrong. I feel like we are done. Should we do the hands-on? Should we mark off the hands-on? Okay, no, that's just too much. Is it too much? Let's just do that. I feel like I'm disrespecting the hands-on lab, but I think there's one hands-on lab. I just gotta do one more. If there's one more, that's bizarre. Okay. Oh no, there is one? Is one more? Okay, there probably is. Okay. Oh yes, we're not done yet. We actually are not done yet. Alright, we have some more questions, guys. These are the questions from the original course. These are the big questions. These are the big time questions. So describe a general data warehousing architecture, and okay, its layers, and distinguish between general and reference enterprise data warehouse architecture. Describe a general data. Question 1 is describe a general data warehouse component layers, and distinguish between general and reference data warehouse architecture. Okay, so they want me to answer it like straight up. Okay, I'm not going to answer it. That's a bad idea. So data warehousing architecture has sort of metadata. It has this diagram I have in front of me. So what else do you want? Do you want components or general data warehouse component layers? I guess component layers are data server, staging areas, enterprise data warehouse repository, data marts, and data analytics and BI tools. So I think I also have the layers here. So they have the integration layer, Yeah, you have the integration layer. Oh, sorry. Data acquisition layer, data integration layer, data storage, analytics layer, and presentation layer. All right, those are the different layers. What else? General and reference. General is a reference is a reference of the general. Has less components and has less on interoperability. Okay, so there we go. Let's move on to question 2. Describe the relationship of a data cube to a star schema, and describe the actions of a slice, dice, drill up, or roll up, and pivot as they relate to data cubes. Okay, so describe the relationship of a data cube to a star schema, and describe the actions of slice, dice, drill up or down, roll up, and pivot as they relate to star schema. Okay, data cubes. Okay, so let's bring it up. Let's bring it up, shall we? Okay, so data cubes relate their online analytical processing. They are cell on a cube. They drill up and down. You can slice, dice, and roll up. The cube represents facts and dimensions, and the coordinates are dimensions. The facts represent the cell. Each cell represents facts and dimensions. So slicing reduces the cube dimension by 1. Dicing shrinks the dimension. And pivoting. Oh yeah, when a data cube is pivoted, the dimensions are interchanged. For example, years and products, what I'm looking at. And for rolling up a data cube, you can aggregate or summarize the dimensions using count, min, max, average, and sum. All right, pretty good. Let's see. What is? Am I missing something, guys? No. Wait, I'm missing something. Of star schema's relationship data cube to a star schema. Because how are they related to a star schema again? Where does it say they're related to a star schema though? Okay, so actually I don't know how they relate. I can't tell you, but I mean, okay, we describe the actions. A data cube is a relationship between the facts and dimensions. And yeah, basically that's true, right? That's true, right? I think I have to send a message, guys. Sorry. Okay. So describe the relationship of a data cube to a star schema and describe the actions of slice, dice, drill up or down, roll up, and pivot as they relate to data cubes. Describe the relationship of a data cube to a star schema. Well, basically, okay. I think I'm gonna have to describe it on my own here, which is fine because I do know it, but I just want to say it as a fact. But okay, so it relates to it. The dimensions essentially are the dimension tables and their columns, and in the star schema going out from the fact table. Essentially, you can essentially the fact table links all of the dimensions together with all of the IDs. And the facts can contain facts basically for those years, and there you go, which is the numbers, of course. But I think you could say the dimension. Yeah, the dimensions are. So what they're saying is weird. All those are the dimension tables, but then you link them with a fact, which is the ID. The ID, yeah, the fact is that. The fact is created because it's linked through the fact table. Next question. Right, question 3. We have describe a materialized view and describe a materialized view and refresh rates and uses for materialized views. I can do that. Let's do it. Hang on. All right, let's do it. Let's do it. Let's do it. Let's do it. All right, so let's see. Describe a materialized view and refresh rates and uses for materialized views. Okay, so where's this thing? Let's see. Okay, so we got it's coming up slowly. All right, so materialized view. Okay, I gotta be careful. I don't want to multitask here, guys. Gotta be careful. Avoiding the multitask. Wait, what's okay?
Daniel, I'm going to fetch Rebecca right now. Bye.
Okay. I think I've done everything I need to do. Okay, materialized views. Read only. Okay, so what did they say? What is the question again? Let's get it fresh in our mind. Describe a materialized view and refresh rates and uses for materialized views. Materialized views are a read-only snapshot containing results of a query. It can be used to replicate data in a staging area. It can automatically keep query results synced to a database, and however, it is likely to work without affecting the source database's memory. Excuse me. Can set up different refresh options. You can never refresh and you can manually refresh. Okay, so these are different refresh options. It kind of does answer the question, but uses I kind of see. Okay, so create materialized view. Okay, so this is sort of like, okay, so this is just showing create materialized view, create PostgreSQL, DB2, but basically this is what the answer is. It's just to fix the source, it can without fixing the source data. So read-only snapshot containing results of a query is used to replicate data in a staging area. Automatically keep query results synced to database. Like lately work with data without affecting the source database. Can set up different refresh options. Never upon there we go. Okay. Okay, so let's see. We did describe materialized view, right? Okay, define facts, a fact table, dimensions, a dimension table, and describe the use of facts and dimensions. Let's get to that. Where is facts and dimensions? Should be somewhere around here. Here it is. Okay, so a fact table is a foreign key that links to dimension tables. For example, store ID. It has detailed information on facts, and it has facts on aggregate. You can aggregate them, generate when process, and it is you can have it's a snapshot. You can have a look at a snapshot of a fact table or a table. I don't know why you'd have fact tables, but yeah. Okay, so dimensions table is a dimension of a fact. Okay, the fact is of fact tables. This is just a fact table, isn't it? Process of a well-defined way. Okay, so the fact tables. Okay, dimensions table, that is a dimension of a fact table. You can aggregate dimensions for business processes, questions, or aiding decisions. For example, filtering, grouping, or labeling. Report is also known as categorical variables dimensions. Okay. Dimensions table contains facts and tables and dimensions. Examples of dimension tables include product tables, make, model, color, size, employee, name, type department table, date, time, granularity of events, geography table, country, state, city, region. All right, example of fact and dimension tables. Okay, so let me go back quickly. This is the schema, right? So create a schema, star schema using fact and dimension tables. Example of schema for fact dimension here is salesperson. So you have sales as the fact table, sales ID is primary key, sales amount, links to first sales ID, first name, last name, birth date, vehicle, make, model, color, sale ID, and so on and so forth. So let's see. What have we got here? Wait, let me. Yeah, we're gonna go back there. Just relax, guys. Just relax. I just want to get this done. All right. I still. Okay. Let me just confirm a few things here, and then I think we can, go full on. All right. Oh wait, let's turn off the volume, make it vibrate. All right, there we go. Much better. Okay, so we'll now list the main steps for populating a data warehouse. Describe methods for change detection and incremental loading, and manually create and populate tables for a sales star schema. Okay, that's the main steps. Let's keep going. We're populating a data warehouse. Where is it? Where's the data warehouse? What is this question again, guys? List the main steps. Oh, did we have to? Oh, is this modeling? Oh, did we mess up or something? It didn't say modeling, does it? Did I mess that up? It says define facts. It's a fact table, dimension table. Describe the use of facts and dimensions. Create the star schema using fact and dimension tables. But I feel like, okay, star schema started process. Then you want to describe it in great detail, which are the dimensions will include the date and time, the date and time sales, but you want to add dimensions such as payment method. These include the facts and these facts products and types. So big schema is on extension of a star schema. Okay, so let's see. Okay, let's keep going. Life. I wish I could just have no life, but I have a life. Okay, so we have create a star schema, product key, cashier, member ID, and they all link. And I link to create the facts. So there you go. Okay, so let me not make a position ID, primary key, store ID, foreign key, data ID, foreign key, cache ID, foreign key, product ID, foreign key, links, product. Okay. Next, what is the question? Populating, right? Let's go to populating. Let's go to populating. So what is the question again? The question was list the main steps for populating a data warehouse, describe methods for change detection and incremental loading, and manually create and populate tables for sales and star schema. Okay, so it is an ongoing, you want to say it's an ongoing process, right? Right, okay. The main steps. The main steps to populate data warehouse is preparation, modeling your schema. Then it's creating your tables for your schema. Then it's verifying your data quality. Then it's your initial setup, creating data warehouses plus the schema. Then it is creating relations in tables, creating production tables, loading the data which is transformed and cleaned. And then it is the ongoing process, which is the ETL pipeline to incrementally load data and append data monthly, weekly, or more frequently. You need to check for changes in the data. and it must meet the schema. So for change detection, there's timestamps to which the criteria when it was modified, brute force checking rows in table with SQL query. You can track changed or deleted records. Change detection is performed archiving or deletion with a script monthly or yearly for data that isn't used or is taking up too much space. Okay, that is it, right? Okay. There we go. I think we did that. I think the main steps actually, if I wanted to list them, that would be, what would they be? I think there would be, okay, preparation, initial setup, then the ongoing process, preparation, initial setup, then the ongoing process. Okay. Define data verification, why organizations verify data, and outline a process for handling that data. Okay, so that's actually 3 questions in one, but okay. So define data verification. Data verification, well, I actually don't have a definition, that's just bad. Okay, so it's just it's checking for accuracy, is data correct? It's checking for completeness, is there any missing data? Checking for currency, is the data up to date? It's checking for consistency, are the fields consistent? And why organizations verify data? So organizations verify data because it costs IBM $3.1 trillion of poor data. That's very valuable. You can integrate data easily if it is more verified. It have a consistent form of truth. Data is easy to lever for competitive decisions, boosts business confidence, and it's readily available, and it's useful. Okay, so is there anything more you want to do? Outline a process for handling bad data. Okay, managing data quality. You detect the problem you see in the data. Then you capture the information of the data quality problem. Then you report the problem to the domain experts in the organization. Then investigate whether there is an upstream error, which is a source process. Then you figure out what is wrong specifically, and then you correct the data. In number 6, you correct the data issues. Now, another example would be, say you have missing data, out of range values, duplicates, invalid values. Create a SQL query to detect for these conditions. Create rules for correcting and managing these conditions. Create a script that runs the data validation queries every night. Number 4, automate the script created in step 3, I think, and perform data detection correction process. Then review the automated report and address issues that could not be resolved automatically. Data quality solutions. There we go. That's surely it. Yeah, then there's a whole lot of stuff there. Okay, so interpret an entity relationship diagram for a star schema. Use the relationships between tables to set up queries, create a materialized view, and apply the cube and roll-up options. Between tables, okay, wait. Interpret an entity relationship diagram. Okay, so this is definitely referencing a reading. Do you want me to go to the reading? Wait, where is it? It's like an entity relationship diagram or something. Okay, I'm not sure. Define a data warehouse staging and describe why staging areas are used as the first step for integrating data sources. Okay, where's data staging area? Staging area. Querying the data. No, it's not querying the data. It's here. Staging area is. Okay, so define the data set and describe why staging area is the first step in integrating data sources. Staging area is the bridge between the data source where data is extracted to the destination system. It is stored in a silo in data warehouses. Data warehouse stagings are decoupled from the extraction of the extraction process required for the system. It's generally transient, meaning that However, the staging area is backed up for troubleshooting. Okay, data warehouse staging areas include PAT files, Python, SQL files, DB2, data. Okay, what else is there? A data will describe the message will change it. Okay, this is all done. Staging area, which is used for the first step for integrating data sources. Okay, what was describe define data warehouse. Question 9. Define the data warehouse staging area and describe why the staging area is used as the first step for integrating data sources. Let's see. Why is it described as the first step for integrating data sources? Why is it described as the first step for integrating data sources? You guys know? Stage. Oh wait, we know. Wait. Okay, hang on. Here we go. So, as the first step, I think I missed something. Why is it doing? Oh yeah, it decouples the extraction phase. Doing it reduces corruption. You can easily back up when you're in the staging area. The workflows for acting to a bridge between the source systems where the data is contracted from and from the source system to the target system. Does it say what it does, Laura? Explain why it's verified for any bad data. Data and outline scheduling first. There's normalization. Okay, let's keep going. Question 9 is done. Alright, this is overall question 9. Question 10, describe fact and dimension tables. What is, okay, describe fact, wait, what? Oh, design, fact and dimension. Okay, this is, wait. Okay, now I'm going mad or something, right? Okay, wait, am I going mad? Okay, design, fact and dimension tables. Yeah. That's a lab. Okay. Describe star schema modeling, facts and dimensions, and explain how you can use normalization to create the snowflake schema as an extension of a star schema. Fact and dimensions. Oh, this is modeling. Okay, we just know this. So must we just go over this again or something? Wait, must we just go over this? Wait. Okay, so this is it. So star schema, the edges, the keys, the relationships linked to the other nodes. Okay, fact dimensions consists of multiple foreign keys and state of 2 tables. And snowflake is dimension tables, split tables. Dimensions, radius, essential fact. From the fact table, edges of relations between facts and dimensions. Star is normalized. If it's normalized, it's a snowflake schema. Okay, modeling designs to select this business process, choose a level of detail, identify the dimensions, identify the facts. Okay, want to develop a plan, okay. HZ, right, dimensions which will include the date and time, you might add other dimensions, payment method, these will be fact tables contained inside dimensions. Then you can include the facts, the columns in the table, in the dimension. Quantity, these facts can be product mark, discounts, quantity, and sales information tags. So the facts are contained inside the fact table, used inside the dimension, which is connected to the star. Alright, so there we go. Snowflake or extension of a star. Snowflake schema is an extension of a star schema. There are many keys. The tables are normalized duplicates, destroyed, well, thing. Okay, so let's mark that as done. Right, we have 2 more to do, and then we're getting this. So populate a data warehouse. We have done this, and then we verify the data quality for a data warehouse, which we did, and build a data warehouse staging area, which we did. Okay, so I don't really have anything more to really cover with that, so we can move on to week 3, guys. Week 3. Hopefully, yeah, the handwriting is all over the place right now. It needs to be at least readable. All right, so the overall questions that we have actually answered we haven't done the individual questions. Okay, so question 1, so introduction to analytics, and so this is okay. So now we've moved on to week 3, Cognos visualization, practical. That's what I called it. So this is where we tried our Cognos Analytics, created visualizations, built a simple dashboard, register and create an account for Cognos Analytics. However, we are not done yet because we have a few questions to answer. Quite a few. Okay, so introduction to analytics and business intelligence tools. Question 1, define analytics. Okay, to be fair, this is not too bad. This is written pretty neatly. This question, okay. Definition of analytics. Analytics is the methodical compilation and dissection of our statistics and operations used to build models and enable better decisions. That's question 1. I think that is, wow, that was really nicely done there. I felt that one I felt pretty good about. And okay, let's keep going. Question 2 is describe how computing tools are currently affecting analytics. So how tools are currently affecting analytics these days? They're affecting the compute stage. Storage is usable in large quantities, and then it goes into more data. Compute process, where it works faster and reduces limitations, also goes into more data silos. Compute's memory is faster, goes into the more data silo, and then it goes into the faster processing results and turnaround. Okay. Let's see. Okay. All right. So that is okay. So it's affecting it by creating faster processing results and turnaround. Let's keep going. Stay on topic. Is the stream still going, guys? Is it still going? Let's see. Surely we've made 3 hours now, guys. Surely we've made 3 hours. Yeah, surely we made 3 hours, guys. Am I just crazy? Surely we've made 3 hours. Is the stream still going, guys? Is it still going? Oh no, we haven't made 3 hours. We haven't made 3 hours, guys. We haven't made 3 hours. Sorry about that. I wish I could make. I wish I could hope your forgiveness. I hope you can forgive me. Okay, question 3 for introduction to analytics and business intelligence tools. Outline the process of analytics and business intelligence tools. Purpose of analytics and business intelligence. And analytics provides outcomes in real time. Descriptive outcomes, what happened in the past. Prescriptive outcomes, what happened in the future. And predictive outcomes, what should happen in the future. What should happen in the future? What can happen in the future? Well, what can be done about it? Or outline the purpose of analytics. I guess it's providing outcomes in real time, and what happened next, what can happen in the future, and what can happen, and it's providing descriptive for what happened in the past, prescriptive for what can happen in the future, predictive for what happened in the. Okay, let's just. If we don't get it, we just move on because we just gotta go. We just gotta go here. Describe what an analytics or business intelligence tool is. Business intelligence. What is a business intelligence analytics tool? It enables data preparation, data mining, data management, and data visualization. It focuses on the what and the why. It applies statistics and operations research. It harnesses the power of descriptive, diagnostic, predictive, and prescriptive analytics. It enables dashboarding, self-serve analytics, and reports. Transform data into opportunity. Very, very nice. Let's keep going. That's question 4, introduction to analytics and business intelligence tools. Continue to question 5. Identify several analytics and business intelligence tools. Examples of tools for business intelligence. IBM Cognos Analytics. It integrates Watson Analytics, leverages IBM AI and natural language processing. Microsoft Power Business Intelligence. It is known for its security and suite of applications. Tableau provides a powerful visualization. Oracle Analytics Tool Cloud, known for conversational analytics. SAP Business Objects, recognized for smarter analytics. Tibu Spotfire provides an AI-infused visual analytics and custom analytics app creation. Okay, let's see. So bonus material. Oh yeah, this okay. We don't need the bonus. Okay, we only were here for question 5. Question 5 is done. Let's keep going. Question 5 is done. And business intelligence tools. So we have okay. So let's keep going. Where is So next one is okay. So the next were all very chill actually. Next were all very chill. Yeah. All the hands-on labs though were pretty chill though. Yeah, the hands-on labs are pretty chill. Hands-on labs are pretty chill. Yeah, hands-on labs. Yeah. I guess there is one thing I guess that we have to do with. Yeah, I mean the hands-on labs were intense though. Let's be honest, guys. Yeah, I don't really know. I don't really know what to say. It's just hands-on lab. There we go. Okay, so let's go here. Accessing your data warehouse with Cognos. Questions or learning objectives. Question 1. Describe the steps needed to access a database in a data warehouse with Cognos Analytics. Question 2. Create an interactive dashboard using data within the data warehouse. Question 3. Add multiple visualizations to your Cognos Analytics dashboard, which we actually did, but not. Oh, question 3, yeah. But question 1, here's question 1. So question 1 asks, describe the steps for the accessing your data warehouse with Cognos module in the week. Describe the steps needed for the lecture in the week. This is the lecture in database in a. Okay, sorry. Question 1 for the. For lecture accessing your data warehouse with Cognos. Question 1. Describe the steps needed to access the database in a data warehouse from Cognos Analytics. Steps to access a data warehouse from Cognos Analytics. Step 1. Identify the databases, schemas, and tables and connection credentials. Step 2. Create server connections. Step 3. Create modules for the selected tables. Step 4. Create a dashboard and add data modules to it. Let's add some full stops here to add some class to my work. Step 5, create. Okay, so step 1, Step 5, create visualizations, drag columns from the data module onto the dashboard. All right, so that is question 1. We're almost getting to ending time, guys. I hope you aren't too sad, guys. I hope you're not too sad. We've hardly drunk anything. It's shocking. It's shocking. Let's drink some more water. As I said before, yesterday, source of life. Okay, so let's see. Yeah, this is actually done, by the way. This is done. This is all done. Now, what kind of questions were there, though? So, question 1. Okay, so for week 3, Cognos visualization practical overview is to try out Cognos Analytics, create visualizations, build simple dashboards, register and create an account for Cognos Analytics. Describe. It says here, describe. Okay, questions or learning objectives. Describe the purpose of analytics and business intelligence tools. Oh yeah, I can do that. So it. Okay, the purpose is to provide descriptive outcomes. What can happen in the past? What's happened in the past? Prescriptive outcomes. What can happen in the future and how you can make them happen? Predictive outcomes. What should happen in the future? And it provides analysis outcomes in real time. Also, the tools that are being currently used for analytics involve compute storage. Storage is what is it? Okay. Wait, but it just said purpose, right? What was the question? Describe the purpose of business. Yeah. The purpose is done. Purpose is done. Okay, identify several well-known analytics and business intelligence tools. Examples, those would be IBM Cognos Analytics, Microsoft IBM Cognos Analytics, which integrates Watson Analytics, leverages IBM AI data processing, Microsoft Power BI, known for its security state of application, Tableau, which provides powerful visualizations, Oracle Analytics Cloud, known for operational analytics, SAP for business objects, recognized for smart analytics, and Tibber Spotfire, which provides an AI-infused visual analytics and custom analytics. Yep, creation. Okay, question 2 in the pocket. Okay, question 3. Navigate around. Okay, we did the navigate around the IBM Cognos Analytics interface. Explore the advanced features of IBM Cognos Analytics. We did that. Build sample dashboards using IBM Cognos Analytics. We did that. Create interactive and advanced dashboards using Cognos Analytics. We did that too. All right, guys, it looks like we're going to move on to probably, this is the, I guess, the money time. This is where we make the, this is like, yeah, this is the tip of the iceberg, as they say. Okay, where's my highlighter? Sorry, where's my ruler? Is it, where did I put it? I lost my ruler, guys. My world has ended. Where is my ruler? Give me my ruler. I am getting very mad. Where's my ruler? I know I haven't lost it. It's just I've misplaced it. Whatever. It sucks. It's probably stuck in the book, which is going to be even more annoying. If it is, wouldn't it be here? Oh, would it be here? Okay, hang on. Okay, come on. You know you're in the book. Okay, let's do this. Okay, it's not in the, wait, still more. Hang on. There we go. Okay, not in the book. Must be somewhere. Somewhere. Okay, guys, that's embarrassing. It was in front of my face the whole time. Did I lose my ruler on purpose? No, guys, relax. Why would I do that? Okay, looks good. Let's. Okay, so do we have to double? We have to double stack. Oh no, we don't. It is double stacked automatically. And we've done the summary and highlights. Very nice. Okay, let's get... Damn it, I wrote them neatly as well, which is also very impressive. Very impressive. Okay, let's do this practice quiz. As we come close to the end of the day. Is it Biz? Oh, wow. Are they serious about this? Is this seriously a question? How am I supposed to know what this is? Whatever. In Cognos Analytics, what are the two main navigational areas of the interface? I think it would be... Oh, for Cognos Analytics, it's definitely left pane. 100%. Are you crazy? Are you insane? It's how would it not be left pane? Are they insane? Okay, we definitely got that right. What happens first when you use the Cognos Assistant to create a dashboard? Oh, just these questions. Okay, to create a dashboard. Okay, I'm losing my mind. It resizes and rearranges your visualization on a dashboard. Okay, so it resizes it and it rearranges it. Okay. It resizes it and rearranges it Okay, it resizes and rearranges your visualizations on a dashboard. Okay, it automatically creates a dashboard. Ah, yes, it suggests, right? I know what that means. It suggests, right? It doesn't automatically create though. It doesn't automatically create, right? No. I don't think I'll pass the practice, but I will go extra. I'll go hardcore for the next one. What are the 2 ways to create calculations in Cognos Analytics? That's search for calculations. Wait. Okay, wait. Select operators and functions from the left pane. Or start typing in the expression box. I guess that's correct. Wait, what? Select operators from the left pane. So that's not right. Search for calculations. Search for calculations. Oh, surely it's just that. I don't even know these questions. Organizations can use BI tools and expertise down there. Depending on statistical models, data analytical tools have a reduced time to churn data so much the results are now almost real time. These analytics outcomes can be okay. Okay. All right. So we're getting an auto correct, an auto tick there, for the fans. Okay, so we failed. It did not actually surprise me. I'm not surprised by this. I knew I'd get this one wrong. This one I'm not. Okay, so this one we got correct. Okay, so this actually. Okay, well this one's obvious. This one's probably just gonna make me really mad. But what would it be then? You can either ask a question. It resizes and it does automatically create a dashboard though. I can't. Yeah, it is actually okay. What am I doing? I'm gonna say a code automatically creates it, auto gens. This actually looks familiar, so I'll try that as well. Let's see if we can get it right. Yeah, guys, you guys shouldn't be watching. I'm a loser. I can't even. Yeah, I can't even get 80%. Come on. So I'm pretty sure it's wait, where's the biz one? Where's the biz one? This is the one. Yeah, Cognos trial. In Cognos Analytics, which it could be TriCog. It could be TriCognos. But Cognos trials is just too logical. Alright, so we know this. This one I think is this, but I have it like a backup. So this one we know. It's this, and then this is the what is it? I don't know what it's called. Easy. Well, not easy, but I mean this one we know. We sort of know it. But maybe we pass. Okay, we didn't pass. That's fine. But we got both those questions wrong, which is not fine. Okay, so we got both those questions wrong. Okay, so this means it's trial Cognos, maybe? Oh, no, we tried trial Cognos. Okay, we have to get this right now, otherwise we can't do... Oh, wait, the Cognos does not help you to create it, but it does not create one for you automatically. So, okay. Okay, wait. Wait, what was the question we did previously, guys? Okay, wait. It's surely not. Surely it can't be that though. Do I want to check? Maybe I should. To be fair, I don't think you can do the graded unless you pass this. So we've got to pause, guys. We've got to pause. So what would make sense here? Try Cognos also rings a bell for some reason. But if they have biz and try Cognos, that's just bad. Okay, let's see. It's not biz, right? Okay, I'm not gonna finesse this. But I really want to. IBM.com. Yeah, I could easily just cheat. Yeah, I could like probably all the people who does this course just looks at everything. What is it? IBM.biz is not right. IBM.com. Okay, well we know it's IBM.com because we can check. Okay, so it's IBM.com, so we know it's IBM.com. Cognos trial, IBM.com. We tried trial Cognos, but we didn't say IBM.com try Cognos. So if we get this right, we're through, right? We're through, right? And then this Cognos does help you to create a dashboard, but it does not generate for you one automatically. But didn't I say? Okay, I don't know. I actually don't know. I know I said this. You can either ask a question directly or ask the assistant to suggest some questions to ask. Okay, well, if it is this, I will be... Okay, if it's that... Okay, so I have a few, like... Okay, we have to get this. We're in big trouble if we don't get this. Okay, let's try. Okay, so here we go. So we have try Cognos. We're going to try Cognos. We're going to try this one. And then we're going to have... Okay, we know this, so we don't have to worry about that. Okay, let's just get all the ones we don't have to worry about. So this one, this. Okay, so this is all good. We just need to get this. Okay. Okay, so you can either ask a question directly. Isn't it just this? Isn't it just this? Okay, try Cognos. I think that's fine. But we tried this. We know we tried this. We know it's not IBM.biz, so this actually should be a secure. What is it? I don't know. An auto kill. So that should be an auto kill. So where's you can either ask a question directly or ask the assistant. You know, if we get 100% for the okay, I don't care. Let's just do it. I think I'll get marked down for a problem, but okay, still 60. Okay, we've actually. So it's seriously this. It's seriously biz. Oh my gosh. So oh wait, what did I get wrong? Oh, did it say right pin? Oh my word. So I actually got it right. Oh, that's bad. That is so bad. I actually could have got 80 here. Oh no. But these things really don't matter. I'll be honest, these things really don't matter. I could try again, but I don't think I'm allowed to. Oh, I can try again as much as I want. Okay, well, I guess we're just gonna try again then. Okay, so then it's biz try Cognos. Sorry, biz. Is it biz Cognos trial? Wait, it's the left pane. This is right. This is this, and then it's this. Oh, sorry, this. Okay, we should pause. Should get 80. I mean, Oh, we got 100. Okay. Okay, now we go to the one that actually matters. Yeah, now we go to the one that actually matters. So about 43% of learners didn't pass the exam on the first try. But don't worry, you can always try again. But only 3 times. So this one actually is the... Yeah, this is where I show my class, hopefully. Okay, so yeah, the other one was a staging area. Totally. In the how to sign up video, which item in the account form is described as the key one to take note of when you sign up for a trial of Cognos Analytics? What? Wait, what is the... Wow, this is savage. Your name? But this is actually correct, though. Okay, what is the first step to build a dashboard in Cognos Analytics? I think that is the first step, to be honest, but provide questions and answers to the assistant. Choose a template. No, it's not choose a template, though. Choose a template's wrong. Template's wrong. No, template's wrong. I know template's wrong. You have to upload something. Okay, which of the following methods can be used in Cognos Analytics to create visualizations? Widgets, automated recommendation visualizations, by using the assistant to suggest questions and suggest visualizations, by manually populating by dragging and dropping. Okay, well, this is definitely true. By using automatic recommended visualizations. This is definitely true. Wait. By using widgets, that does not... Okay, it does not create a visualization. It's just questions and suggested visualizations. These 3 are obvious. This one's not so obvious, but it could be true, but it's not obviously true. How can you create infographics in Cognos Analytics? I can think of a lot of ways, but drag and drop a widget shape icon into a visualization. This is this is so obviously it. It's bizarre. There are many solutions available in the market that empower organizations with the ability to perform advanced analytics. Which solution offers scalability for small and large organizations? Okay, let's see. Small and large. Small and large is not this. This it could be. This is, everyone knows it's trash. But Tableau is definitely, definitely Tableau, right? It's definitely Tableau. I could look at my book right now and cheat, but I'm not gonna. Well, I don't even know if it's cheating, but Tableau. It's obviously Tableau or Oracle Analytics. I like Tableau a little bit more than I like Oracle because Oracle feels weird. I know Oracle's about something, but then again, Oracle does feel right in some areas. So Tableau. Let's see, guys. Let's see. Should we go for Tableau or should we go for Oracle Analytics? I'm gonna go for Tableau. Why not Tableau? Tableau, yeah. It's Easter Sunday. We can go for Tableau. Okay, so organizations can use BI tools built-in expertise to analyze data and find patterns using machine learning based on statistical modeling. As today's analytical tools have reduced the time to churn data so much that the results are now almost real time. Fill in the blank. Okay, these analytics outcomes can be descriptive. I think it's descriptive. Wait, descriptive, predictive. It's prescriptive. Okay. All right. So this actually does look okay. We're definitely going to pass, right? Because it's just 66%. So we're going to pass. This feels right. This feels very right, though. Okay, this feels very right, right? Okay, this one feels very right. Okay, step 2. Okay, upload. This also feels very right. Okay, so this one, but is it this? Select visualizations, provide questions, answers, choose. It just has to be this, doesn't it? doesn't it? Choose a template. No, choose a template, copy it. Choose a template is after you've uploaded it. Okay, hang on. I have to just check something. Yeah, that was good. That was a good one, though. That was a good one. Okay, let me just turn it over. Okay, upload a sheet note. Choose templates. Either, if I get that wrong, it's obviously choose a template. These ones, again, by using widgets, you can't really create a visualization. You need to have some columns with you. You can create an infographic with widgets, yes. But as I said here, and then... Okay, this one I think I could have got this one wrong. Yeah, all the other ones is quite a good chance I got it right. Yeah. So I probably predict I got 5 out of 6, like at worst 4 out of 6, but there's no way it's less than 4, and there's no way we didn't pass. Okay, so we got 66. What is the things we got wrong? Upload a spreadsheet is wrong. Upload a spreadsheet is wrong. Okay, so this one we got right. This one we got right. Okay, this one's obviously right. Okay. So this is okay. So we're gonna take the test one more time. Try and see if we can finesse a nice high mark here. But we did pass, so we are on to the next course. Wait, which ones is it? Business analytics, operational analysis. And by the way, guys, I don't care about the marks. I care about the hours put in. And clearly, you can look at the stream. There's hours put in, and that's all I care about. Business analysis. It'll all be worth something one day. That's just I believe it'll all be worth something one day. And then I'll be the one laughing, and pretty literally all the way to the bank. So data analysis. Interactive data, operational. Business analysis is there. It's all there. But I don't want to go to the next item, though. Hang on. I don't want to go to the next item, though. Let me go to week 4. Let me go to week 3. Week 3 is not done? What do you mean week 3 is not done? Week 3 is done. Week 3 is done. Why is it not? I need to get that green. I need to get that side quest. I need to get that quest completed. Okay, I've completed the quest. 100% completion. But I didn't do well in the mini games. I didn't do well in one of the mini games. I need to do well in one of the mini games here. Let me see if I can do well in the mini games. All right, here's the mini game. All right, so we're gonna try again. I know the answers now. I have to get it. So closest data center is obviously right. Choose a template has to be right, otherwise that's just bizarre. But we did beat 43% of people. Like 43% of people didn't fail. It failed the first time, so we passed it first time. So we are pretty good. So there you go, guys. You probably shouldn't be watching, but yeah, you should watch like for my effort. I put in the most effort. That's just me, man. How can you create infographics in code? Okay, so we also drag and drop a widget shape icon into a visualization. There are many solutions available in the market to empower which shows what storage places. It is Oracle. Organizations can use BI tools. Okay, so this is we know this prescriptive. So now let's see if we can finesse a nice little 80 here. Okay, we got a nice little 80. That's good enough for me. I knew I'd get 80 because I knew I'd get template, but this one I think, yeah, this one is sort of, but then it must be Microsoft. I'll take the L though. I will not take the, yeah, I'll take the, what is it? I won't be yeah, I'll lose my respawn. I'll lose my respawn for that. I'll lose my respawn. Okay, let's move on to next week. Let's see. We've done 6 out of 5 days for the week. How about that, guys? That's the record, right? 6 out of 5. Setting a standard. Setting a standard. Getting more than you can actually get. Okay, now we move on to week 4, which of course is probably the most exciting week in these sort of things. It is the final assignment and quiz, and of course I'm assuming you guys are all very excited about this final assignment and quiz. I know I am. So let's keep going. Week, what is this? Week 4 for the course, getting started with data warehousing and BI analytics. There's been some controversial weeks during this course, or should we say quests, but we have finally got there. So final assignment. And for all you guys wondering, have I sat here since 9:30 in the morning and literally not moved and just recorded myself streaming? Yeah, it's true, guys. It's true. It's true. You gotta live the life, man. This is called living it up. This is called living it up, guys. This is called living it up. Final quiz. There we go. Okay, this is week 4, final assignment and final quiz. I know we're not going to underline it. Let's go to the overview. Okay, so we're going to make a nice overview here, guys. Okay, so the overview, in this module, you'll complete your final course project, which brings together concepts and practices you previously learned in the first 3 modules. In this final project, you'll design and load data into a data warehouse using facts and dimension tables. Then you'll write aggregation queries using cube and rollup functions and create materialized query tables, known as a materialized view. You will complete your project using IBM Cognos to create an analytics dashboard. Okay, so load data. Okay, so let's see. Populate data, right? Populate data. Load data into a data warehouse. Into a data warehouse using fact and dimension tables, which is all good. So we'll be writing aggregation queries. We'll also write rollup and cube aggregation functions, as well as creating materialized views. So lots to look forward to, guys. Lots to look forward to. I can't wait. I know I can't wait. In fact, I'll probably do. In fact, I'm looking forward to it so much. I actually might do it after we end it. After we have to end at 6, guys. We just have to end at 6. We just have to end at 6. It's just a rule I've sort of come up with. Well, I've had it for a few, maybe, I don't know how long I've had it. Probably a week and a bit, maybe more than a week, maybe 2 weeks. But it's just a nice little rule. Just nice rule. Okay, everything in check. Create a materialized view. Okay, so you will complete the project. Okay, we will be completing the project by using IBM Cognos, by using IBM Cognos IBM Cognos to create an analytics dashboard. I am going to forget everything. Hopefully I don't forget everything. That is the goal. I don't want to forget everything that I've just learned. That would be really bad. Okay, so questions or learning objectives. Questions or learning objectives. Let's keep going. Okay, questions or learning objectives. Question 1. Design a data warehouse. Question 2. Load data into a data warehouse. Oh wait, let's write it properly. What am I doing? I'm actually. Oh, it's getting to the end of the day. It's quite sad. Load data into a data warehouse. If I'm still streaming now, I'll be pretty happy because then we've at least made 3 hours. And I'll be happy if we make 3 hours. I'll be happy. It's better than nothing, you know. I mean, I was hoping for 7 or 8, but hoping for 8 initially. Okay, question 3: write aggregation tables. Right. Must remember to do the washing up of the dishes. What else is there to do? Right, aggregation queries. Ask Rebecca. She's good. Oh, there's the name again. Hey, yeah. That's my sister, by the way. But just forget I said that. Okay, question 4. Create materialized query tables and create a dashboard. Create materialized query tables and create a dashboard. All right, cool. This is good. I think this covers it. Right? Materialize query tables and create a dashboard. There we go. All right, let's keep going. So let's highlight everything to make it look professional for me when I look back on it, which I may have to, which I probably will actually have to, because you know we always, it's just a rule. We go back, we check, we make sure we just go over it to make sure everything's nice and thorough, and we keep going. So final assignment, and final quiz. Yeah, I thought they were going to say final assignment again. Final quiz. Let's keep going. All right, so overview. There we go. Questions, learning objectives, highlighted. Let's begin, guys. All right, final assignment. Here we go. So we want a project overview. Does any of you want a project overview? I do. Let's get a project overview, and I'm the only one who matters. Okay, so we've got a whole lot of questions here. We could write them out, but yeah, I'm not going to. Okay, so let's look at project overview. I mean, if there's anything I feel I need to write out, I will. Okay, let's say reading project overview. All right, project overview. Let's keep going. Is the what's the majiggy-mabob still running? Let's see. Is it still going? Oh my word, it is. Nice. 3 hours 27 and counting. This is good. This is good. We've done a pretty good documentation of the amount of work I put in. Now you guys will finally now people will finally know that I don't do nothing during the day. This is what I do. And I'm going to be doing it tomorrow. No questions asked. I'll do this tomorrow. I would do this even if you paid me not to do this. I would still do it. Alright, so instructions. Now that you are equipped with the knowledge and skills to work with data warehouses, you will use these skills to design. Okay, so instructions. We will. Okay, instructions. We will design. What are we gonna do? We will design and implement a data warehouse. Data warehouse for a company. What is it? While using, well, okay, in the hands-on labs. Maybe I should have summarized that, but okay, handwriting off the charts, terrible here. Okay, so let's go to the scenario. What is the scenario? You are a data engineer hired. We are a data engineer hired by a solid waste management company. The company collects and recycles solid waste across major cities in the country of Brazil. The country operates hundreds of trucks of different types to collect and transport solid waste. The company would like to create a data warehouse so that it can create reports. Okay, let's see. The company, we work for a company that keeps track of the solid waste that is disposed of geographically. What is it? First set amount. It's first set amount, right? For amounts. With the amounts are recorded. The amounts of waste disposed are recorded. Yeah. Company has lots of trucks and there's lots of trucks. Let's write that properly. Company has lots of truck types. And okay, the company in Brazil, by the way, this is in Brazil, company in Brazil would like to produce reports, and I think it's important that we all remember that this is fictional. This is not real, guys. So for the people who are actually intelligent watching, this is fictional. Relax. Yeah, the people intelligent enough actually able to do anything about this. This is fictional, right? Relax. Okay, so there's waste. We're not incriminating Brazil here. All right, so we have total. Oh, wait. Do we need to write this down? Oh, the grading criteria doesn't matter. Can't we just create like a? Can't we just open this in a new tab? Let's double tab this. Let's go here. All right. So this is important. I will write this out. Reports detailing. Reports such on details such as. All right, we have the following: total waste collected per year per city. Okay, per year per city, and then total waste. I think we're gonna make a space here. So I mean new line. So total waste collected per month. Total waste collected per month per city. I think the per city seems to be pretty important. Total waste collected per quarter per city. Total waste collected per quarter. Sorry, per quarter per city. Let's keep going. I'm gonna get a job because I'm sure I'm gonna get it. I'm gonna be like I'm sure I'm gonna get a job. Yeah. I'm gonna become CEO of Google because of this. Dude, I couldn't care less. I hope I don't actually get a job because of this. Okay, so total waste collected per truck type per city. Total waste collected per truck type, per station, per city. Total waste collected per truck type, per station, per city, per city. Okay, let's keep going. This looks pretty important, so let's make sure it looks important. This looks like something we're gonna definitely need to keep in mind. Refer to, I don't know if we're gonna need to refer to it though. Grading criteria, there are a total of 28 points possible for this final project. The final assignment will be graded by your peers who are also completing this assignment within the same session. Your grade will be based on the following tasks. Task 1, design the dimension table, dim date. Task 2, design the dimension table, dim waste. Task 1 point, task 1, design the dimension table, my dim date, 2 points. Task 2, design the dimension table, my dim waste, 1 point. Task 3, design the dimension table, my dim zone, 1 point. Task 4, design the fact table, my fact trips, 2 points. Task 5, create the dimension table, my dim date, 2 points. Task 6, create the dimension table, my dim waste, 1 point. Task 7, create the dimension table, my dim zone, 1 point. Task 8, create the fact table, my fact trips, 2 points. Task 9, load data into the dimension table, dim date, 1 point. Task 10, load data into the dimension table, dim truck, 1 point. Task 11, load data into the dimension table, dim station, 1 point. Task 12, load data into the fact table, fact trips, 1 point. Task 13, create grouping sets query, 2 points. Task 14, create a roll-up query, 2 points. Task 15, create a cube query using the columns year, city, station, average waste collected, 2 points. Task 16, create a materialized query table named max waste per station. Max underscore waste underscore per underscore station using the column city, station, truck type, wax waste collected, 2 points. Task 17, create a pie chart on the dashboard, 1 point. Task 18, create a bar chart on the dashboard, 1 point. Task 19, create a line chart on the dashboard, 1 point. Task 20, create a pie chart on the dashboard, 1 point. How to submit screenshot of the data is required to draw the screenshot of the services to front from the student throughout the process. There will be short of the process submit the this course. It's like this, and let's get okay. Oh wait, we mark it as complete. What do you mean mark it as complete? As a reading, it is complete though, so I'll complete that. Okay. Identify requirements for your analytics system. Is this a read? What is this? What is this? I don't understand. Hang on. Alright, so apparently Easter Sunday is actually important to people. Okay. Whew. Well, the show must go on, guys. It's not. We gotta go till 6. Let me close the door. And we are back. I hope I don't need the toilet. We're going into our last sort of session. I don't know if you guys can hear me. Now you can hear me. We are back. Let's see. How long have we been streaming? Okay. Oh, am I out the room here? Oh, okay. Let's see. I think it's working. Sorry, is it working? How long have we been streaming? 3 hours and 40 minutes. We're almost at 4 hours. Okay, we almost at 4 hours. The problem is that I have an additional 2 hours that I can add to this, and you can literally see it on my profile. So it's kind of disappointing. And in 8 minutes as well. Okay, so here we go. So this is a reading. Okay, hang on. So we're gonna get started on this reading. Let's get started on this reading. Okay, here's our reading. So this is a reading. What is the reading on? Identify requirements for your analytics system. That is what we want to do here. Identify requirements for our. Yeah, yours doesn't sound right, guys. Yeah. For our analytics system. Sounds very nice. Alright, so wait, hang on. System, as they say. Okay, so reading. So let's just underline it here. This is all I don't know what this reading is about, to be fair. I can't really. What is it about, guys? Can you tell me? What is this about? Oh, you guys can see I worked for 4 hours. Oh, there you go. You can see, but it actually is more. It actually is more than 4 hours. I think it's more. Yeah, it's 7 hours, but minus 1 minute and 36 seconds. Then we work for 7 hours and 21 minutes. So we do some work today, guys. Yeah, we only got 82%. Yeah, had to fail 3 times. Yeah, exactly. That's the life. That's just life. When it comes to the final exam, that's all that matters, though. That's all that matters. You can't fail that. Well, you can, but you have to well, whatever. Let's keep going. In this assignment, you'll be designing a data warehouse for a solid waste management company. Here are a few things to keep in mind before you proceed to build a data warehouse. Okay, so it's a few things to keep in mind. Keep in mind before. Well, I think it's while. Is it before or while? Okay, so it's before you create your data warehouse. Yeah, all the people thinking that I'm gonna die, I'm gonna run out of steam. I want to give those guys some news here, guys. Here's some news for those people. I am literally more motivated to do more hours tomorrow than I was ever in all the streams so far. So tomorrow we're going for the 8, uninterrupted. And even if it does get interrupted, I'll still keep going. I don't whatever. So keep it. Well, again, I don't want to make promises that I can't keep, but I definitely will be studying, whether on stream or off stream. I can keep that promise though. Keep in mind before you create your data. Well, hopefully. Okay, so here are the following things: organizational level analytics requirements. There we go. Let's keep going. Identify what are the analytics requirements that are needed. Okay, so what are the analytics requirements? What are the analytics requirements? Requirements across all levels of the organization. It's a big deal that I failed the test 3 times. I passed in the end, so you can go to hell. Okay, where's the next one? So there's more than one. Let's keep going. Oh wait, let me highlight the reading. Okay, so reading, identify requirements for our analytics system. Analytics system. So this is our analytics system. It's gonna be, as they say, yeah, they always say streamlined. Okay, so it's gonna be streamlined. Okay, let's keep going. Department level analytics requirements. Department level. Oh wait, we're not gonna be able to finish it. Oh, I'm just realizing, wait, there's no way we can finish it. Guys, look. Guys, can you see what I see? Can you see what I see? Can you see what I see? Wait. Yeah, you can. Wait, let me just check. Okay, so this is on. Virtual camera is on, so you can see it. So there it is. This is 1 hour 30. So 1 hour 30 goes over 6. So that is a problem. So we could so we could like sort of overanalyze a few things maybe. We could sort of go over the assignment, make some comments. Yeah, maybe have like what do they call it? Like choose your like add some extra like items so that we have like bonus health and stuff. So yeah, bonus intelligence, exactly. So there's department level analytics. Identify what are the analytics requirements that are needed at the level of various departments, or at wait at the level or various at the level or various departments in the organization. Okay, so we've done reasonable amount, I say. Okay, let's keep going. Oh, sorry, course 9. Oh wait, did we not even do it on that page? Yo, that is so bad. Oh, it is done? Okay. I think I auto-gen that. Wait. Let's go to course 9, week 4, module 1. It's FA, dude. It's FA. This is FA, guys. This is FA. Come on. If you don't know what FA is, then then get away from my channel. Like, go away. Like, this is South African. Okay, let's keep going. Okay, so we need to keep part of like the department analytics requirements, the organization level requirements. There's departments and organization. Okay, so then we have our performance analytics requirements. Analytics requirements, which apparently are a thing. So performance analytics requirements. Performance analytics help organizations to track how its operations are being carried out. For example, these reports include how many products sold in the last quarter. Performance analytics, how many in the last quarter. Sales room, excuse me, used per product. Total sales per product in the last month. Let's keep going. Okay, so how many? So this is how I operate. Okay, so this is track operations. How do they track the operations? They track the operations in the following ways. How many products? How many products sold in the last quarter? How many products sold in the last quarter? What else is there? There's how many products sold, how many tons of raw material used per product, how many tons of raw material used per product. Okay. Let's keep going. Okay, so let's see. So for example, these including reports like, we looked at these reports. So to track operations, reports include, yeah, I'm totally doing, like, I'm such a programmer. I'm just like losing my mind. I'm losing my mind in programming language. Yeah, my mind is only speaking to me. Okay, how many products sold in the last quarter? How many tons of raw material used per product? Total sales, total sales per product in the last month. Okay, there we go. So we have done. So we've got to worry about organizational level analytics requirements. We've got to worry about department level analytics, and we've got to worry. Okay, so we've got to worry about performance. What's an organizational requirements across organization, department level or level various departments. Performance analytics requirements. Track operations include how many products sold in the last quarter, how many tons of raw material used per product, total sales per product in the last month. So yeah, there is that. I'm just gonna. I think I could do all. I don't actually know. This definitely isn't a learning objective, but let's keep going. All right. We have 20 minutes, and yeah, guys, I'm gonna miss this session. Yeah, it actually, it's gonna be sentimental. I mean, hopefully I can create many more, but if my computer died or something, I wouldn't be able to. But this is probably well, it's not I want to, it's just I want to, well, here there is one. Okay, let's focus. So granularity of reports. Granularity of reports. So let's see, granularity of report. Did they just wait? Hang on, what do you mean a granularity of reports? So granularity has an impact. So we've looked at identify requirements for your analytics system. So you have to keep in mind certain requirements such as organizational, department, and performance. Let's look at granularity. So granularity of reports is a major impact on the data warehouse design. When you identify the grain, you specify exactly what a fact table record contains. The grain conveys the level of detail that is associated with the fact table. When you identify the grain, you also decide on the level of detail you want to make available in the dimensional model. If more detail is included, the level of granularity is lower. If less detail is included, the level of granularity is higher. The level of detail that is available in a star schema is known as the grain. Each fact and dimension table has its own grain or granularity. Okay, each table, either fact, in brackets, either fact or dimension, contains some, now normal, so it contains some level of detail that is associated with it. The grain of the dimensional table is the finest level of detail that is implied when the fact and dimension tables are joined. For example, the granularity of a dimensional model that consists of the dimensions date, store, and product is products sold in the store by day. Identify if the organization, if the organization needs reports year-wise, quarter-wise, month-wise, week-wise, day-wise, or hour-wise. That's what we need to identify. Identify if the organization needs reports at country level, region level, state level, district level, or individual store level. So this is the granularity. Okay. So I'm going to do my own definition. I know you guys are probably going to get really upset with that, but sorry. I'm just going to have to do that. Okay, so let's go here. So granularity has its own. Okay, granularity refers. Do I know no one's watching? Of course I know no one's watching. Why would anyone watch this? Granularity refers, and if you are watching, whatever. Okay, granularity refers to the level of detail. Each fact in a fact each fact and dimension table. Okay, the level of this was known as each fact and dimension table in a star schema are grains. Increase the granularity. Wait, this they said it better, right? Makes its own granularity from the fact and dimension tables. Okay, let's get some chill stuff here, guys. Let's get some chill stuff here. Okay, so remember, so granularity is level of detail. Let's say that again. Granularity is level of detail. Okay, so granularity is level of detail. Let's keep focused. Stay on the topic. Okay, so let's see. Okay, so each fact or dimension table is a grain. So okay. Oh wait. Okay, wait. The fact table is associated with the grain dimension one. Okay, so let me just get it right here. So the granularity is the grain occurs the actual the fact table measurements when you verify the grain derivative is known as the grain. Has its own grain or granularity. Each factor has its own grain or granularity. Okay, that does make more sense. I.e., the level of detail. Now, of detail, the grain. Okay, so is the finest level that was applied when the fraction joined. Okay, I'm not gonna write that because let's get real here, guys. Let's get real. Okay, for example, the granularity of a dimensional model that consists of the dimensions. Wait, what is it? Of the dimensions date, store, pre-recorded. I love that if people are thinking this is pre-recorded, they're insane. I would love this to be pre-recorded, but that's just bizarre. Okay, anyway, let's focus. And product. Actually, to be fair, I don't know what pre-recorded actually means. Is product sold in store by day? So, for example, the granularity of a dimensional model that consists of the dimensions date, store, and product is the product sold in store by day. So basically, that's a cube, right? That's a cube, right? That's a fact cube, right? That's a fact and dimension cube. All right, that's a fact and dimension cube, and I'm starting to realize I'm not writing this very neatly. Identify the. Okay, so we need to identify a few things. Okay, let's write this here. And it is related to this. Okay, so identify if the organization needs reports year-wise, quarter-wise. I was hoping to get it down. Okay, quarter-wise, month-wise. Stay on topic. Week-wise, wow. Week-wise, day-wise, wow, or hour-wise. Okay. We go into the next level here. Okay, identify if the organization needs reports at country level, region level, state level, district level, or individual store level. Okay, or individual store level. So this is needs to for the country level, region level, store level, district level. So again, this is all examples of granularity. I am gonna do a little bit of a. You guys won't see it, but I'll do a little bit of a. Why am I caring about you guys? Let's just stop caring about you guys. All right, let's keep going. I prefer it that way. I don't know if you guys prefer it that way. So let's go here. I'm speaking to no one, exactly. Okay, I know I probably am speaking to no one, essentially, but in case I am, I've got to say stuff. All right, because I'm not checking the chat. Okay, let's see. So this, I don't know. I feel like we could do. I feel like I like this. I feel like this time, when we did it last time, it worked. So just drawing the line. Let's keep going. And now it's the okay line. Where's this line go? Here's the line. All right, 10 more minutes, guys, and we have to call it a day. I don't know how long I've streamed for, but let's check. Let's check, guys. We're getting close to the end, I think. So diagnostic analytics requirements. Well, we're actually gonna. Oh, we could end this thing. So you guys probably want me to end it. That's. Where is? Oh, this is wrong. This is wrong. This is wrong. Okay, 4 hours and 47. Alright, I'm gonna say it's a 5-hour stream because that's just what everyone does these days. And I'm gonna do, so we need to look at diagnostic analytics requirements. Analytics requirements, and these are as follows. So what are diagnostic analytics requirements? Can we finish this now? Guys, just relax. Diagnostic happen, for example, was it which is no other process decline these trends over a period of time. Okay, want to know why keep products sales have declined. I could keep all these records on my phone, on my computer. I could keep all the videos on my computer. Yeah, totally. I don't need to do this. There's a lot of reasons why it's actually on YouTube, because it's essentially it's like being on the cloud. So think about that. I could private it, maybe. Okay, let's see. These analyses of trends. Let's go for an example here. E.g., total sales of a product for the last 10 quarters. Total sales of a product for the last 10 quarters. I want to finish it for the fans, guys. I want to finish it for the fans. Yeah, it makes my studying a lot more fun, knowing that I have a responsibility to actually do it, and I have fans as well. So yeah, it motivates me to study more and achieve more excellence. Whether I want to get a job or not is totally, and it's a very interesting. It's a very interesting question. Okay, sales for quarters. Find where sales declined. Sales declined. Okay, let's keep going. Sales for a product, country-wise, and then identify which countries prefer a particular product. Let's keep going. Stream is about to end, guys. Yeah, stream is about to end. Chill. Let's see. I wonder if anyone's watched the stream now. I don't think anyone will watch it now, but when I put it on WhatsApp that it's a 5-hour stream, I think people will watch. I think they'll pay a little bit of attention. The only reason why I do this, guys, is just motivation for studying and to record and to have a record. And also it's good memories as well. And if you think that I actually care about you guys, I think I've said it many times. I literally don't care about you guys. Okay, one more, and then we're out of here. In the stream when I finish this, there's always more we can do. Week 4, module 1. Yeah, there's always more we can do. As I said, I'll look into the assignment. Do some extra preppuccino. All right. Yeah. Is it what do they call it? The Rapid Chess Championship? Definitely. All right. Let's keep going. Ad hoc analytics requirements. In spite of all the requirement collection process, it would never be possible to collect or anticipate all the analytics requirements. So we need to design a data warehouse. So when we design a data warehouse, we need to keep in mind that there will always be an ad hoc analytics requirement that comes up from time to time. The data warehouse design should be in such a way that it should be able to accommodate ad hoc and analytics needs to some extent. So ad hoc, there would always be an ad hoc analytics requirements. Okay, data warehouse should be able to accommodate for sudden changes needed to be done to the DW data warehousing system. All right, ad hoc changes, as they say. Well, I think that's what ad hoc changes are, but if I'm wrong, I'm wrong, I guess. So, okay, let's keep going. Analytics requirements, let's keep going. Doing pretty well here. Chillin'. Oh yeah, there's something else I need to do. Wow, I actually need to do that. Wow, I completely forgot about that. Wait, oh, okay. That was bad. Okay, this market is complete. Let's teabag this thing, as they say in Prison Break. Let's keep going. Hang on, wait. Okay, teabag. I forgot what his real name was. Okay, wait. Gary Neville, this thing? No, come on, guys. Don't be cruel to Gary Neville. Everyone knows he does look like Teabag, though. Okay, here we go. Hands-on lab, final assignment. Do I want to make some comments, or should we go over the objectives? I usually don't, but I'm feeling like in a generous mood today, guys. Hands-on lab, final assignment. For all you guys wondering if I feel like I have purpose, dude, I feel like I want to crack cocaine. I have that much purpose. Trust me, I feel like I have purpose. Okay, in this lab, you will use real-world examples to demonstrate the skills you have practiced in other labs. You will design, create, populate, and query a data warehouse. Skills Network Labs is a virtual lab environment used in this course. Upon clicking the Open Tool button below, your username and email will be passed to Skills Network Labs will be used as strict coordinates. Instructions. Do you want to view it like this, or do you want to view it in the terminal, guys? Hang on, we're gonna have to close these things. Sorry, guys, we're gonna have to close these things. Oh, we had the. Okay, let's bring it back up. Let's be smart here, guys. Okay, here we go. Oh, technically we don't need to do that. Yeah, we don't actually need to do that. We can just go here. It's literally 2 minutes. I know, it's 2 minutes. I know. Talk about making use of your time. Okay, final assignment, introduction to data warehousing. Estimated time needed, 90 minutes. Of course, as we all know, that is an hour and a half. Okay, about this skills network mags. Okay, so we complete this type of using cloud-based PostgreSQL and MySQL database using the Docker container. All right, do you guys want to count down with me? You guys want to count down with me? All right, let's count down with me. All right, let's count down. All right. All right, important notice about this lab environment. Please be aware that sessions for this lab, having a clock in front of you is so intimidating. A new environment is created for you every time you connect to the earlier session. Wait, connect to the server? Is it the server? Should we just not look at the time? I don't like looking at a clock. It will. Okay, should I just end the session now? Okay. Total waste. Total waste. For truck type. You'll use data warehouse skills to implement data warehouse for the company. Objectives. Oh, that wasn't. Oh, I'm so bad. In this assignment, you'll design a data warehouse. Dashboard. Okay, note screenshots. Okay, it's too late, guys. Goodbye. Have a good one. I'll see you tomorrow, hopefully. And goodbye.